I would like to inform all the partners also, all the participants, that I'm recording the session. All the sessions of the previous 3 days are already uploaded into International Relations Office channel, and I have already sent you the links. Okay, Riyad, the floor is yours. You just go to share screen.
Yeah. Oh yes. Okay.
Fantastic. It works.
Okay.
Nu, tu mai sunat.
It's okay now?
You should open the presentation because we can see just your computer.
Okay. Okay. And now it's okay?
No.
No.
I mean, if you have any difficulties, you have already sent me your presentation, so probably I should download your presentation and we can do it from my computer, but I think that you can do it from your computer.
I can do it. I can do it just the It's okay?
No?
No.
Let me find your... If you stop sharing your screen, I will share my screen, and whenever you would like to change transparency, you will tell me next slide. I will do it from my computer, okay?
So I will send it to you.
No, I have it. I have it. You have already sent it to me.
Just have update it in some slides. Okay.
Okay, I mean... I think it's better to stop sharing and I will do it with the old version. It will take a lot of time now. Atgu, look, share your look. Share your desktop. When you are doing sharing, you can select what are you sharing. So please do share your screen again and share your desktop because over there you have opened the presentation.
I have sent you the presentation.
Stop sharing. Stop sharing. Otherwise, I cannot do anything.
Okay.
I have not received anything yet.
No.
Can we start with the old version and we can forget the two extra slides?
Okay. And now you have received it. It's okay.
Okay, we are starting with the old version. I cannot wait.
Okay. Okay.
Okay, man. Let me share my screen. So the floor is yours, Riyad. You can see my
Yes.
screen, and so I will change whenever you will tell me.
Okay.
Can we start?
Okay.
You can see my screen. On my screen, now we can see your presentation. First of all, relax. Can you see my screen?
Just
No,
I see your video
my
now.
screen, my friend, my screen. Can you see my screen now? I'm sharing your presentation with all the people. I mean, do the other participants, can they see my screen?
Yes.
So, Riyad,
Yes, we do.
just follow my screen. Your presentation is over there. I will change.
Okay, 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 okay.
Okay, let's go.
Can I start now?
Yeah, of course, you can start whenever you want.
Okay, okay. 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 So, I am Ashgur Riyad from Faculty of Technology, Department of Electrical Engineering, Al-Wad, Algeria. So in this presentation, we have to present some overview about 5G technology, challenges and requirements. So the contents, so why the 5G, why the challenges, 5G vs 40 vs 5G, numerology of 5th generation, millimeter wave, massive MIMO, and NOMA. The other slide. So why the 5G? Why the 5G? We know that in the previous generation, for the first G, second G, 3G, until 4G, we have the problem is how to have a good throughput. For example, for the first G generation, that's just the throughput is about 9 kilobits per second. For the second, for the second G, about 9 kilobits per second. For 3G, about 1 megahertz, megabit per second. For the 5th generation, just about 10 to 10 megahertz, 10 megabit per second. For the 5G, we have, or we want to have a lot of gigabits per second. So 5G, the 5G, the end of the G, is to have smart cities, to have smart agriculture, smart building, HD videos, remote surgery, remote driving, self-driving. So all these things, we have to have it with 5th generation. So the other slides. So 5G challenges. So the challenge of 5G are frequency bands, development and coverage, security and privacy, cost to build. 5G needs what we need. And the question, the first, and the important question is what technologies to meet the needs of 5G. So the 5G technology promises faster connections, more reliable data streaming, and a variety of new capability that can bring new opportunities. Other slides. So the frequency band in the 5G, we have two categories. So below 6 gigahertz and above 6 gigahertz. For the below 6 gigahertz, we have greater than 1 gigahertz, less than 1 gigahertz, that are 800 megahertz, 700 megahertz, and 9 megahertz. Also, we have 400 megahertz. Also, we have from 1 to 6 gigahertz bands that are 1.8, 2.3, 2.6, and 3.3 and 3.8 gigahertz. Above 6 gigahertz, we have from 1 to 10 gigahertz, and from 10 to 100 gigahertz. We considered this range as millimeter waves, and also more than or greater than 100 gigahertz. 100 gigahertz means from 100 to 300 gigahertz. So the higher frequencies, can give us more wide bands. The other slides. As we have said that we have two types of frequency ranges defined in 3GPP: sub 6 gigahertz called FR1, and millimeter wave range is called FR2. The exact frequency range for FR1 sub 6 gigahertz and FR2 millimeter waves are defined below. So we have two tables here. We have two tables. Sorry, we have three. So FR1 from 450 megahertz until 6 gigahertz, and FR2 frequency range designation is from 24 gigahertz until 52.6 megahertz. So this the table 5.2 represents the new radio operating bands in FR1 according to the EET, ETU and Telecommunication Union organization. So the other slide. So what 5G needs? 5G needs more throughput,
Adzgu, we lost your voice. Speak now. No, we cannot hear you. Okay. Can you hear us?
You hear me? No?
Now we can hear you, but you have 15, like more, not more than 20 minutes from now.
Okay.
Okay.
Okay, sorry. So I will continue. Sorry. So we continue. 5G needs more throughput, about from 1 to 10 gigabit per second. Latency less than 1 milliseconds. Bandwidth 1000 greater. Number of connection is 100 or 100 or more devices. Perception coverage is about 100%. Enabling new service like device to device, machine to machine, which require. Donc, technology to be used is millimeter wave, massive MIMO, OMA and NOMA, beam management. Technology to be used. So the way when we compare between 4G and 5G generation, donc the most part of 5G is implemented in 5G. Small features of 5G is modified in 5G. New implementation in 5G are different terminology: massive MIMO, millimeter wave, beam management, and LTPC and polar code. So numerology means what it means. Numerology in 5G, it means subcarrier spacing. So the numerology in 4G, we have just one numerology in 4G, but in the 5G numerology we have multiple numerology. So we start with 4G. So we have the frame structure. We have the frame structure. So the length of frame structure in 4G is just 10 milliseconds. It's just 10 milliseconds, and we have 10 subframes. The length of each subframes is 1 milliseconds. It's subframe divided into 2 time slots: time slot 0 and time slot 1. And in each time slot we have either 6 of the symbols or 7 of them symbols, depends on cyclic prefix. So in normal cyclic prefix we have 7. We have 7 of them symbols, and in the 6 of them symbols we have used extended cyclic prefix. So we continue. So as we have said that that in the 4th generation LTE,
Riyad, just a moment. I'm using, because you cannot share your screen, I have shared the screen with your presentation. You should inform me when I should change transparencies. Otherwise, I cannot follow you.
Okay, sorry. I will. Sorry. A slide. You said the slide numerology 3. Numerology 3. You see?
But you can see my screen. Am I right?
No, I can't see it now.
You cannot see my screen?
No.
I think that we should stop. But you can see my screen. Everyone checks my screen. So you should be able to check my screen.
Okay, I see it now. Sorry. I'm very sorry, sir. I'm very sorry.
So are we on the correct transparency?
Okay. Numerology, yes, this slide, yeah.
Okay.
Numerology. Okay, I'm very sorry, sir. So numerology means subcarrier spacing. So in the numerology, we have one numerology, and in the 5th generation we have multiple numerology. So the other slides. So in 4G LTE we have, so please the other slide. So the frame structure of 4G, each frame, the frame length is 10 milliseconds. Each frame divided into 10 subframes. Each subframe divided into 2 time slots, time slot 0 and time slot 1. And in each time slot, we have 7 WFDM symbols or 6 WFDM symbols, depending on cyclic prefix. So the length of one frame, subframe or subframe is the same for 4G and the 4G and 5G. And but the radio frame structure different. So the next slide. So in each time slot we have physical resource block, as you see in the screen. Physical resource block. In the resource block we have either 7 symbols or 6 symbols, and we have 12 subcarriers. So the other slide. So the space between subcarriers is 15 kilohertz. In 4G, always 15 kilohertz between the subcarriers. So each time slot contains one physical resource block, and each physical resource block contain 84 resource elements, normal in the case of normal cyclic prefix, and we have 72 resource elements for the case of extended cyclic prefix. So we have 180 kilohertz in the frequency domain, and we have 0.5 milliseconds in time domain. So the next slide. But in 5G, what's the difference? The difference that we have several numerology or multiple numerology. So we have this table as you see here. Each numerology depends on mu. We have mu equal to 0, 1, 2, or 3, or 4. So we have delta F. Delta F is the spacing. We have if mu equal to 0, spacing equal to 15 kilohertz. If the mu equal to 30, we have if mu equal to 1, the spacing between subcarriers is 30 kilohertz. And for if mu equal to 2, the subcarrier the space between carriers is 60 kilohertz. It is 60 kilohertz. For the last one, mu equal to 4, we have 240 kilohertz. 40 kilohertz. So we repeat that the frame length in 4G and 5G is 10 milliseconds in 4G and 4G, but the difference is in the space between subcarriers. So the other slide. So this table. So as I have said, in 5G there are multiple nomology. So for mu equal to 0, the spacing is 15 kilohertz, which lead to 180 kilohertz in the bandwidth. 180 kilohertz. The number of symbols is fixed. The number of symbols is equal to 14. The number of slots per frame. For the first case, we have 10 slots, or we have 10 slots. For mu equal to 1, we have 20, and for the last one, 4, we have 160. So for all these spacing number, the number of symbols is the same slot. It's the same launch is different. Total of 14 of the symbol in each time slot for all circular spacing. Number of slot is also different. Okay, so the next slide. Well, yes, here. So in the first case, where mu equal to 0, so we have 12 subcarriers. The bandwidth equal to 15 multiplied by 12, we have 180 kilohertz. For mu equal to 1, the bandwidth equal to 360 kilohertz, and for mu equal to 3, what? Yes, to 720 kilohertz, and the last one for mu equal to 4. The subcarriers, we have 12 subcarriers with spacing equal to 240 kilohertz. So the bandwidth equal to 2,880 kilohertz. The other slide. Now the 5G frame structure. It's very important. So as I have said, that in the radio frame we have 10 subframe equal to 10 slots and 10 milliseconds So each subframe in the first case we have one in the subframe we have just one time slot, one time slot. And even in each time slot, we have 14 symbols. We have 14 symbols. The other slide, please. In the second case, where mu equal to 0, in this case, each subframe divided into 2 time slots, and each time slot, the length of each time slot is 1 millisecond. And fourth slot. So in each slot, we have 14 symbols with a length of 0.5 milliseconds. So the other slide. So in this case, with mu equal to 2, in this case, so each subframe divided into four slots with length of 1 millisecond. In this case, each slot length is equal to 0.25 milliseconds. The other slide. The other slide, please. So in the other for mu equal to 3, we have each subframe divided into eight slots, and equal to 1 millisecond. So in this case, each slot length is the length of each slot equal to 0.125 milliseconds. So in this case, where mu equal to 3 with spacing equal to 180 kilohertz. So please. So in the last one, with as I have said, one radio frame equal to 10 subframe equal to 10 slots. So each subframe divided into 16 slots, into 16 in this case, into 16 slots with length always 1 millisecond, but one slot, the length of each slot here is 0.685 milliseconds. So other slide. But how we calculate the bandwidth in this case with different numerology? How we can calculate it? But how we calculate the bandwidth of the channel in different cases of numerology? So Another slide. So we have this equation, channel bandwidth equal to the number of resource block multiplied by the number of subcarrier multiplied by spacing subcarriers plus guard band. So in the first figure, we see in blue the active resource block. We see the active resource block, and the table below, this table, according to FR1, the maximum transmission bandwidth configuration. So NRB is the maximum transmission bandwidth. Bandwidth. So this formula, channel bandwidth, I repeat, equal to number of resource block multiplied by number of subcarriers multiplied by subspacing between carriers and plus the guard band multiplied by 2. So the other slide, the next. So in case, for example, where we want to calculate the bandwidth in case of 60 megahertz in 60 megahertz. So at first, as we see that the number of source block for 60 equal to 79 resource block. Number of subcarriers equal to 60. The number of subcarriers, equal to 12. The number of subcarriers multiplied by the space between subcarriers equal to 60 kilohertz. In this case, the number of source block multiplied by the number of subcarrier multiplied by subspacing equal to 79 multiplied by 12 multiplied by 60. We can see that the bandwidth equal to what? Equal to 56 gigahertz points 880. So not 60, but in the table below, in the case of 60 megahertz, in the case of 60 kilohertz, we know that the guard period equal to 1 gigahertz 0.5. So when if we added this, if we added the guard period, the guard period multiplied by 2 with 56 gigahertz point 880 kilohertz, we can find 60 megahertz. We can find that bandwidth equal to 60 megahertz. Okay, so the other slide, please. But in 5G, what's the difference? What's the difference, please? Millimeter wave. Sorry, the slide, please. So yes. So for the millimeter wave, the millimeter wave range is from about 30 gigahertz until 300 gigahertz. But industry is considered that we can consider that the millimeter wave ranges from 10 gigahertz until 300 gigahertz. So to study the millimeter wave frequencies, we should know some characteristics. For example, in this figure, that from 164 until 200, so it is we can't study the millimeter wave here in this range from 164, because studied that the millimeter wave in this range affected by vapor, by the vapor absorption, so and rain. So also in the range from 57 gigahertz until 64 gigahertz, absorbed this range absorbed this range of this range of frequencies, or this band of frequencies from 57 until 64 gigahertz, affected by the oxygen. So ETU and telecommunication union proposed millimeter band to study it. So for example,
I'm sorry, you have 5 more minutes. We should complete this session in 5 minutes to start the next one. Okay.
Sorry. So as I have said, ETU proposed millimeter wave bands. So this table, this table of proposed by ETU, so we see that some frequencies to study it. So from 2024, the first band 24.25 until 27.5 gigahertz, until the bands 81 until 81 gigahertz to 86 gigahertz, 86 gigahertz. So the other slide. Please. So the massive MIMO, the system using the massive MIMO is first adopted to improve the spectral efficiency of the system, of 5G system. So the massive MIMO system, the system using massive MIMO arrays to serve multiple users to double massive MIMO communication systems. So massive MIMO systems are able to combat the strong attenuation, of millimeter wave signals, so providing the wireless backhaul and suppress interference. So the table below, so we have some current receivers of massive MIMO. So antenna configuration, channel models, description of channel measurements and modeling, channel estimation, efficient estimation algorithm for pilot reuse, pre-coding and detection, performance and limitation, practical applications, resource management, interference controlling. So the other slide, please. So, and now no orthogonal multiple access NOMA. Why this technique, why this technology is to improve the spectral efficiency, is to improve the spectral efficiency, is to improve spectral efficiency. So please, the other slide. So what is the difference between OFDM and NOMA, and how we have improved, and we have how we have improved the spectral efficiency? So in conventional 4G networks, as not an extension of OFDM, orthogonal frequency division multiple access is used where information for each user is assigned to subset subcarriers. But in the case of NOMA, if the customer, each user can have the whole of the whole of subcarriers. So thank you very much. Thank you very much.
The microphone.
11 Greek time. Είμαι ξεκάθαρος. 11 Greek time.
First of all, you should switch off you should mute your microphone. Any question? Thank you, Azgu, for the presentation. Any question?
Thank you very much. Thank you for all Erasmus team. I'm sorry for this.
No, don't worry. This happens. Of course, we wish do not happen, but happens. Any question? So I have one, Azgu. Since I'm not from this topic, so to be honest, I did not understand
Okay.
a lot of things, but because I'm not from this topic, a lot of questions that we have received, they are related with the health impact of 5G. I mean, do you have any comment to make?
Health impact.
Yeah, I mean,
the impact of
probably, my question is very stupid because I don't believe that there is any.
no.
I would like to ask.
About health, I haven't any ideas about the impact, the health impact of 5G.
Excuse me?
You have question. You have a question about the health. Okay.
Yeah.
I don't know exactly.
Okay. All right.
Okay.
All right. So thank you very much for this presentation. Let's make a break of 5 minutes until to give some time for the people to log in because the webinar starts at 11. And in 5 minutes, we're going to start. Okay. Thank you. Thank you, Azgu. And we start.
Good morning, everyone.
So, before we, Professor Mohammed Salah, yes, please go ahead.
Just I excuse myself to go to join for 1 hour for another webinar. So,
Okay.
Thank you. Thank you.
Okay. So let's make a break of 5 minutes in order to start the second session and give more time to people to log in. It's better before we start the second session to have all of our microphones mute. And when we would like to ask a question, then we can unmute our microphone. And hopefully we will start at 11. Before we will start, I will make a short presentation, what it will follow, and then we will move to the schedule. I would request from Brian Luraki to mute her microphone, please. I think from what can I see, we have the first two speakers. They are with us. It's, Maria Boura and Professor Karagianidis.
Good morning.
Good morning, Maria.
Can you hear me? Can you see? Okay, I had some connection
Okay.
problems.
We can see you and we can hear you very well. Before we will start, I think I will start with a 3 minutes presentation. I can see also Ricardo is with us. Ricardo is one of the organizers. He comes from Canary Islands. So I will make a very fast presentation of what it will follow. I would like to thank all the participants. We had already an introduction from a colleague of us from Algeria on the frame of our International Week. So now we move to the main menu with the presentation on the frame of the Erasmus Days 2020 and this webinar in 5G communications. I have to excuse myself that I'm not an expert. I think that I'm not an expert at all from this topic, since my PhD and my research is in laser physics and nanomaterials and nanotechnology. But as you will see, we run a European project to develop an open educational resources on the needs of the fourth industrial revolution. And one of these needs is 5G communication as a game changer, and also is along the priorities of our department, the Department of Electronic Engineering in Hainan. So I will make a short presentation about what we would like to do, and then I will jump immediately to Maria. Let me, because people are still logged in, so I should accept them. So let me share my screen. And so now I think that you can see my screen, and at the same time I should admit the people. So thank you very much to be with us in this 5G communications and applications webinar. We're going to start at 11 o'clock local time, and the program is full until 4 o'clock local time. So the webinar is on the frame of our strategic partnership project, Critical Skills for Electronic Engineers of 2020. And also we are very happy as a university that we have awarded one of the European universities calls, and the next 3 years we are going to work together with other 7 universities in Europe in order to become one university, which is a very big initiative from European Commission, and actually is the dream of the European Union to operate as a whole, to also aware the European citizenship across Europe. So this is the project, what we are developing, and now we are on the final stage. We develop semester modules on critical skills that the electronic engineer will need for the next century. And among these skills is the knowledge on 5G communications. And that's why this is the objective, and the motivation. Why do we organize? And we have invited all these scientists from the academia and from market to present to us, this excited technology. On the frame of this this project, we develop a semester course as an introduction to 5G communications, and like Associate Professor Evangelos Kokinos, who is responsible for this development. This is the schedule. I mean, you can find all the information from the website that we have on the frame, within the frame of this webinar. So we will start with Ms. Maria Bura from Ericsson, and she's going to provide, I think, a very nice introduction about 5G and why 5G is like a game changer. And then we will move to the rest of the participants. All the participants, they have a slot from 15 to 20 minutes to the questions. I have to say that we should be very strict with the timeline, because some of the participants, they have to participate, as I have informed you before, to meetings. So we don't want to delay them, and also would like to keep the coherence of the presentation. So the first presenter, and we would like to thank her a lot, is Ms. Maria Bura from Ericsson. The title of her presentation is 5G Made for Innovation. She's a physicist. I'm very glad about this, because I'm a physicist within an engineering department, and sometimes we should defend our impact in a friendly way. She also is the director of government and industry relations in Ericsson. So I will stop sharing now my screen, and I will give the floor to Maria. Maria, you have 20 minutes, as I have informed you. please, during the sharing, share the computer audio in order to enjoy your videos.
I'm trying to do that. Tell me when you see my screen.
We can see your screen.
I don't know how I can take this away. Good. Good. How can I take this away? Do you know? Hide. Okay.
Okay.
Yes, I do. I want to take this away. All right, great. Thank you very much for the introduction and the opportunity to be here with you today. I will try to walk you through 5G and why do we believe it is really the most versatile innovation platform we have ever experienced. So let me start. I mean, these are the three areas I'm going to touch upon today. I hope within my time, I will do my best. So let's see, first of all, 5G, some people talk about it as it is something that is coming in the future. Well, it's not coming in the future. It's already here. It started commercially already last year in 2019, and already today, less than 2 years after, we are at 101 commercial 5G networks in 44 countries and 222 commercially available devices. At the end of the first year, we had already 17 million subscribers. Just to give you an idea, when 4G was launched, the first year, at the end of the first year, we had about 3 or 4 operators had launched commercially. At the end of the first year of 5G, we had 60 operators launched commercially. And we had back then about 3 or 4 devices, something like that, commercially available. At the end of the first year of 5G, we had already about 40 devices available. So you can see already, not only that it is here, but it is growing extremely fast. It's the first technology that is growing so fast. And in fact, you can see here in this graph that 5G is expected to reach 1 billion users faster than any other technology ever. And you see here the credit card, it took 74 years to reach 1 billion. The Facebook users, it took 12 years to reach 1 billion. Even the Instagram took 8 years, and we expect in 3.5 years to have more than 1 billion 5G subscriptions. And Ericsson estimates that, in fact, that by 2025, we're going to have 2.8 billion 5G subscriptions, and almost half of the total traffic of our networks is going to pass through 5G networks. So it's a phenomenon. And let's try to answer the question, what is really this 5G? Why all this fast? Why is it going so fast? Why everybody is talking about that? I think if I was trying to find a way to picture that, I think you should think of 5G as the spinal cord and the nervous system of our society and our economy. That's what it is, that's what it will become, and it's becoming very, very, very fast. But let's see a video which helps us to understand maybe a bit better about that.
2G, 3G, 4G. They've all revolutionized the way we live our lives. And Ericsson has been leading the way. So when it comes to 5G, it's easy to think it's just another G. Well, it's not. With 5G, things will be faster, and we mean a lot faster. With global mobile data traffic doubling every 18 months, the world's demand for high-speed connectivity increases every second. And that's where 5G comes in, by efficiently providing the capacity for massive data growth. So what does this mean for you? It means high-speed connections for everyone always. Fast and uninterrupted sharing, streaming, and browsing, so that you'll never have to fight for data, no matter the competition. But it's not only about speed. 5G will reduce latency to a minimum, making delays virtually impossible to proceed. It means elevating reality even further. It means fiber speeds without fiber at home, for everyone everywhere. And with network slicing technology, every connected service can get its own unique part of a 5G network, fully dedicated and guaranteed for each specific purpose. It means the Internet of Things on an industrial scale, making society more sustainable, increasing resource efficiency, connecting vehicles to get there both faster and safer. It means protecting the most vulnerable road users, detecting accidents before they happen. and helping save lives with dedicated networks for critical services. With Ericsson's leading 5G technology paving the way, the full potential of connectivity is becoming reality. Join us. Let's explore 5G.
So basically, I hope with this video, you managed to see different use cases, different ways that we're going to use 5G, and different capabilities that it has. Basically, 5G is a network that has been, it's the first such network actually, mobile network, that has been designed right from the start to be very, very flexible and very adaptable to dynamically allocate resources when and where is needed and fulfill completely different requirements. It's as if we are in the beginning of the electrification back a couple of centuries ago, when the electric current was going to come into our homes to light, to bright our nights, basically. Who would imagine back then that we would have electric washing machines, refrigerators, kitchen stoves, sound systems, TVs, even cars and so on? Nobody could imagine that. We are at the same place right now with 5G. We cannot imagine the applications that will really come, but we have built a network that uses all the latest technology. Cloud is there, artificial intelligence and machine learning is there, edge computing is there, network slicing is there, massive MIMO is there, just name it, virtualization is there, software-defined networking is there. So everything is being used to cater for a very flexible network. And we can see that in the areas, there are four big areas or big use cases, you can say, that 5G is called to cover with completely different requirements. The first one is fixed wireless access or wireless fiber as it is called. So to try to connect the unconnected or to connect rural areas where it is not commercially viable to go with fiber. Fiber costs a lot and takes a lot of time. Why? Because it needs civil works, it needs digging, it needs permits. And it can take a year to reach to a home that is remote with fiber. Well, we can cut this time down to 3 months with 5G. And we can cut, of course, the cost as well. So you can imagine this is a big part. And we have seen in the US, when it was launched 5G last year, it was the first country to launch 5G. This was the main initial use case. Then there is a second use case, which was also on the video. What we're doing today with our smartphones, enhanced mobile broadband, to do it better, faster, with high reliability. And in fact, consumers, we have asked them, and they expect higher speed, better coverage, better improved reliability, responsiveness, and quality of service. So a better user experience. And we'll see about that. Then there are the big thing, I think, about 5G is the two other areas, because these two, the fixed wireless access and enhanced mobile broadband, more or less we had it also before. We know what it is. It's just better. But we have two other very important areas, which is the massive IoT. Here we are talking about connecting millions of devices. We're talking about having up to 1 million of connected devices in 1 square kilometer. To give you an idea, today with 4G, we're talking about maximum 10,000 connected devices per square kilometer. So we're talking about smart meters, sensors, actuators, imagine, I don't know, environmental networks of sensors in Natura 2000 areas to measure environmental indices and see and cameras and so on. If you have this kind of connected devices out there, and of course, because there are too many, you don't want, and you cannot. First of all, they send small amounts of data, so they don't have usually big requirements in terms of data throughput and data speed. They don't have either latency requirements. It can reach, I mean, a smart meter measurement can reach in 1 hour, in 2 hours later, it doesn't matter, nothing will happen. But they need to have a very high energy efficiency, because if you have millions of devices out there, you cannot go out there and change batteries every year. So you have to have a battery life of 10 years. And that's what we're talking about in this area of massive IoT. And then you have a completely different set of requirements for another use case, which is the critical IoT. And here we're talking about high latency, we're talking low latency, we're talking about 1 millisecond, near real time. When you're doing a remote mammography or a remote surgery, even worse, you cannot afford that the latency, you have to have real time, or an autonomous car, because an accident will happen if it doesn't break on the spot. So you need really, really high reliability, extremely low latency, 1 millisecond, very high availability. And usually you also need a lot of data to be able to be sent. For example, if you have a fireman being in the fire and with the camera transmitting back to the operations center what is happening in the place of the fire, this needs to really reach fast and reliable and with high data rates and data volumes. So you see that it's so different requirements, yet one network can take care of all these requirements. And that's the beauty of it. And that's why 5G is an open innovation platform like we have seen never before. So let's go and see, and that's why it's a critical national infrastructure as we talk about it. Let's see a little bit of 5G use cases before I come to my end. So first of all, 5G has been launched for consumers. This is the first use case, the easiest one. I told you about in the US, mainly for fixed wireless access, so used as a wireless fiber. In Southeast Asia, like South Korea, Japan, and so on, we see a lot of entertainment, gaming, sports and events, and education applications. And instead of talking, I'd like to show a video of the launch of 5G by South Korea Telecom at a stadium. Look at what you see. What you see. I'll stop it here for the essence of time, but what you see is something that doesn't really exist right in front of your eyes. So you see an augmented reality show through your smartphone, your laptop, or maybe your tablet, or maybe special goggles and so on. And this is what we've seen in terms of consumer-based use case and applications, at least in the first launches of 5G. So we've seen things like that, like virtual shopping, AR-based shopping. So you can try on products without being there and then order them. You can see kids' books becoming real in front of their very eyes, like three-dimensional. You can train with an AI coach, which corrects also your posture. You can go on a virtual date with a star. You can have a neckband, like a camera, 360 degrees camera, and transmit whatever you are taking at that time. Or you can have esports tournaments and play with different players and friends and so on. And this is what we've seen in terms of consumer applications that have been launched. And we are going towards, we believe, selling experiences and not data plans. Talking about the internet of senses, we go towards this kind of things where you will be able to experience petting your dog without the dog being there. You can experience taste without really the kid being there. And you can experience, of course, meeting with someone and hugging them and talking to them and touching them without being there. That's where we are heading towards. So that's for consumers. And I'm going to round up by giving a few information about 5G for business, which is the biggest actually part of 5G is addressing industries and the economy. And that's why the big fuss about growth and about how much 5G can contribute to growth of countries and competitiveness and so on. And there, this is just a very schematic view of things we have done trials since 2016. Just to give you an idea, for example, we're talking about transport solutions, autonomous cars, self-driving cars. When you have self-driving cars, maybe you will not need the driving wheel anymore. Maybe you will not need to have driving licenses anymore. Maybe if the cars talk to each other, why do we need traffic lights? And if you can really have car as a service, then you don't own a car, so you don't need a parking lot at home or at the office, because you will have the car to take you and then get away, and you don't care about maintaining and so on. So big changes are going to become possible through self-driving cars. Other areas where we have seen is the connected port. I mean, port is areas with great activity and so on. I learned recently that the people who are driving the cranes, this is a very, very dangerous job. And for safety reasons, they have a 4-hour shift. They cannot work more than that. What if they could do that and drive the crane from the comfort of their home or of the operation center of the port and not being up there on the crane? Then they could maybe drive more cranes at the same time and have a better productivity. And then, of course, safety of the port, faster loading and unloading of ships, and so on. Then Industry 4.0, of course, one of the biggest, the most important segment that is going to benefit from the 5G capabilities that I mentioned before. And these are just samples of the trials and pilots and things we have been running with different companies like ABB or Audi or Mercedes or Scania or Osram facilities or General Electric and so on. And here you can see when you go into a production environment, there is a lot you can do if you have wireless connection that is highly reliable with a very low latency and very high data capabilities. You can connect robots. For example, automotive industry, if they want to launch a new car model, they have to reform the production line, and it can take them up to a year to do that. If this year goes down to 3 months, you can imagine the immense increase in productivity and revenues for the company. And then if you can have the expert there at any time that something happens, remotely connecting through augmented reality and guiding the operational guys, you can imagine what that means for operational efficiency, and so on, just to mention a few examples. A lot of things to be done in this area. And I would like to close this part with the mining. Why? Because for me, it was a fascinating example. For example, in a mine, we have worked with Boliden, which is the largest mining company this is mine, the largest mining company in Sweden and one of the largest in the world. When you go into a mine gallery and you do a blast, for reasons of safety, you cannot send down their people immediately. It has to pass a certain number of time period. What if you could, though, send trucks which are being driven from the surface? So the driver sits in the operational center and the truck is down there. What if you could do that? You could save a lot of money and you could have your people more safe. And once you do that and you go into the mine with this kind of capabilities, then you say, okay, maybe I can put sensors in the rocks and detect early rock movements so my people are safer and I can detect early if something bad is going to happen and evacuate them. And then more than that, they say, 2% of the total energy consumption in Sweden goes for the air conditioning of mines. What if I could automatically switch on and off air conditioning only when people are there and is needed? How much the savings would be for the environment, first of all, but also for the companies. So you see, this is the mentality. You go into one industry to fix one problem, and then once you have all these nice capabilities at your hands, you come with more and more and more applications and use cases. And this is what I said before. We don't know today what the applications really of 5G will be tomorrow. And that's why we have designed a network, which is the network of networks, and is so flexible and can reallocate dynamically network resources on demand where it is needed and in the way that is needed. And I'm closing with one last video just to show you from one customer of ours. It's AT&T in the US, and I think it's a good closure of what is doing.
Connections, they're all around us. But what if they became even smarter, reshaping how we live and how we work? Imagine a future where self-driving cars could connect to the world around them and make decisions in near real time, where doctors could see things they've never been able to see before, and retailers could use augmented reality to create a better shopping experience. As businesses explore new applications and services, they'll need a next-generation network to support their innovations. And with the AT&T vision for 5G, entire industries could be transformed. This edge-to-edge solution will deliver ultra-high speeds, ultra-reliability, and ultra-low latency. But more than just speed, 5G will be smart. And AT&T plans to deploy 5G as a software-defined network with enough intelligence to transition between wired and wireless networks, delivering optimal performance. So a manufacturer could identify and fix machinery in record time, An insurance company could use drones to assess disasters in near real time. And a first responder could see through walls and smoke, saving lives faster than ever before. In a world where milliseconds matter, 5G from AT&T will provide new opportunities for business and ultimately unlock a world of endless possibilities.
So this was from me. I'm stopping sharing. Thank you very much.
Thank you, Maria, very much for this nice presentation. Actually, I'm looking forward to getting a taxi in Athens with a taxi driver to read his newspaper, and I will feel very comfortable. So, we have time for a couple of questions. I can see on the chat already the questions are over there. So we have a question from a student, Dinos Chakalakis. So how the 5G correlates with hologrammatic technology? I don't know if you understand the question. So how the 5G correlates with hologrammatic technology? I have no idea. I mean, I cannot.
No, me neither. I'm sorry, I cannot understand this.
Okay, so let's move to another question. I mean, if you have any question to Maria, please raise your hand or try to switch on your microphone and ask it directly. There is another question from a student. On Crete, we have problems of coverage and signal instability. Will 5G make things better on this part?
Well, actually, coverage is one of the main things that consumers are asking for coverage, but this has to do with having more base stations deployed. So this has to do with deployment barriers. So if you don't have enough base stations, you will not have enough coverage. So as long as the government and the states everywhere, not only in Greece, do not resolve this issue, I mean, the easiness to deploy new base stations, coverage cannot be fixed. I mean, it's not a miracle. I mean, it has to have more base stations.
All right. Thank you very much, Maria. All right. One of the other students, tries to elaborate a little bit the first question that I made to you. Hologram means VR technology in 5G.
Yes, so, holographic technology, we've demonstrated in 2018, the first holographic concert in Southeast Europe in collaboration with our customer Cosmote. Two of the people of the band were playing in one room, two of the other people were in another room, connected via 5G, and the holograms of the two people who were not in the same room were playing all together, and the band was playing properly. And we have also showcased the holographic call. The minister was talking to the mayor of Zographou, and the mayor was in hologram in front of him. So yes, this of course is one of the applications of 5G.
And I think one more question from the chatting, and then I will give the floor. Please mute your microphones if it's possible. There is another question: in how many months do you predict for 5G to dominate the market? Of course, we have other talks that they are going to cover this, but the question comes to you.
Yes, as I mentioned.
Maria, you are muted. Muted.
I don't know why. Yeah, sorry. But we expect to have 2.5 billion, 2.8 billion subscribers, 5G subscribers by 2025. And also we expect 5G to cover, I think, 65%, if I remember, of the population by the same time. So it's going very, very fast. I can give you more information, and you can find more information in the Ericsson Mobility Report. If you search for that Ericsson Mobility Report, in June 2020, you have all the predictions for 5G.
Thank you, Maria. And last one, because it comes from a student, so this is the last one, but it's not dangerous to depend on 5G. What will happen if there is a technical problem and everything is connected with 5G? I say this because you said that everything in the future will be based on 5G.
Yes, it will be based on 5G, and that is why security, this is a very good issue, of course. Security is a very, very important aspect of 5G, because if you have the spinal cord and the nervous system, you cannot afford it to break down. You're very, very correct. That's why you need to make sure that you have security by design, but that's not enough. You need to do a lot more, and that's why there is this big discussion in the European Union, as we speak, with the EU toolbox that all countries need to implement in order to safeguard and ensure that 5G networks are going to be highly secure. It's going to be like as if the electric grid, what happens if the electric grid goes down? We cannot afford that happening. You're very, very correct. It's a very big issue, this one.
So thank you very much, Maria, for this nice presentation.
Thank you. And any questions, just to say, Konstantinos, if anybody has any questions, you can reach me LinkedIn, Facebook, wherever. I mean, I'm open and I will be glad to answer. Okay? Thank you.
Thank you very much. So now it's time to move to the next speaker. The next speaker is like a very distinguished professor and academic, and it's Professor George Karagiannidis. Professor George Karagiannidis is a professor in the Electrical and Computer Engineering Department or in Aristotle University in Thessaloniki, and also is the Director of Digital Telecommunication Systems and Networks Laboratory in this university. So please, Professor Karagiannidis, I don't know, I think that you are with us. I have seen you before. You can share the screen with us. And
I'm here.
Thank you very much, Professor Karagiannidis, for the honor to be with us. And just to inform all the attendees that all their questions, they have been registered, and our presenters, they will try to reply to all of them in a very short time.
Okay, thank you very much for the invitation. I'm very happy that I'm the next speaker after Mrs. Bura. Mrs. Bura is an executive in Ericsson. Ericsson is one of the major vendor in 5G systems. Also, I'm very happy that because among the audience, I can see many of my students, and this is very important for new people, for new researchers to attend the technology, and especially the 5G technology, which will dominate the next, let's say, 5 years. I have slightly changed the title of my talk, and now the title is The Fundamental Technologies of 5G and Beyond. I have added the word beyond because the 5G is not a single standard, but actually this is an ecosystem which includes many technologies, and some of them are now under discussion for the next years, and I will focus on this technology because other colleagues will focus on the technologies that are already included in the standard. Okay, my name is George Karagiannidis. I'm a head of the Wireless Communication Information Processing Group and founder of the group at the Electrical and Computer Engineering Department in Aristotle University of Thessaloniki. I will talk about 5G and beyond technologies, and let's start with a very simple expression, which is the area capacity. My talk will be, of course, more technical compared to Mrs. Bura's talk. So I hope that among the audience there are some that knows the fundamentals of communication, etc. Okay, here we have the area capacity in bits per second per square meter, which is the goal of every communication system, to increase the area capacity. If we can split this expression in 3 ratios, the first ratio is the spectral efficiency, bits per second per hertz per node. Actually, this is the spectral efficiency per node. The second term is the node per square meter, which is related to the network densification. And the last one is the spectrum, hertz, the spectrum. Okay, let's see the 5G technologies that are connected to these 3 parts of the area capacity. Spectral efficiency. We have better spectral efficiency in 5G systems through the use of massive MIMO, non-orthogonal multiplexes, interference management, new methods in interference management, and full duplex transceivers. Regarding spectral efficacy, I will focus in the rest of my talk on the non-orthogonal multiplexes, because I guess that Massive MIMO will be covered by other colleagues, and especially from Professor Kanatas. Regarding the second term, which is the network densification, also this is very important. That's very important and very critical for the 5G networks. We have 4 concepts, 4 technologies: the small cells, the cloud radio access networks, the device-to-device communications, and the coordinated multi-point. And the last but not least, term, the spectrum. Maybe spectrum is the most important term in this expression. If we remember the Shannon capacity formula, we can understand why. So, regarding the spectrum, we have the carrier aggregation. I guess that also Professor Kanatas will talk about that. The move to higher frequency bands in millimeter wave, 50 to 60 gigahertz, and also to terahertz, 0.3 terahertz. And the last is the optical wireless communication, which include both visible light communications and infrared communications. As I said before, I will focus in the rest of my talk in these 3 technologies with red here, which is now under discussion to be included in the standards in the next few years. Okay, let's start with non-orthogonal multiplexers. What are the disadvantages of using orthogonal multiplexers? Orthogonal multiplexers refers to the well-known time division multiplexers and frequency division multiplexers, TDMA, FDMA, and TDMA, and where each orthogonal block can serve a single user. Okay. But the spectral inefficiency of orthogonal multiplexers can be understood with the following simple example. Let's consider a scenario where we have one user with very poor channel conditions needs to be served for fairness purposes. For example, this user has high priority data or has not been served for a long time. In this case, the use of orthogonal multiplexers, for example, TDMA, means that it is inevitable that one of the scarce bandwidth resources is solely occupied by this user, despite its poor channel conditions. Obviously, this has a negative impact on the spectrum efficiency and throughput of the overall system. The second major disadvantage of using orthogonal multiplexers is the difficult to support massive connectivity. Massive connectivity is also a very critical goal of the 5G system. 5G and beyond aims to support very high throughput, low latency, heterogeneous application, and massive connectivity. Okay, before I will give you a brief description of the concept of non-orthogonal multiplexer, let me say a few words. Non-orthogonal multiplexer has become an important principle for the design of radio access techniques for 5G systems. NOMA is now under discussion in 3GPP, and there is a very recent study. I cannot remember now the number, but if there is any question, I can send also the last draft study on non-orthogonal multiplexers. Although the application of NOMA in cellular networks seems to be relatively new, and in the last, let's say, 5 years, we have 1,000 papers on non-orthogonal multiplexers, relative to NOMA concepts have been studied in information theory for a long time ago. For example, key components of NOMA, such as the superposition coding, the successive interference cancellation and the message passing algorithm have already been invented more than 2 decades ago. The basic concept of NOMA is that we have one more dimension. So far, we had 2 dimensions, and let's say 3 if we add also CDMA, but let's say 2 dimensions in an axis scheme, frequency and time. Here, we have one more direction, which is the power. We can see here in this figure that we can use also the power dimension in order to increase the spectral efficiency. In other words, we can transmit on the same frequency, on the same time slot for 2 users. I have an example that I will not, I have an example in my next slide. Also, I see the time. Here we have a base station and we have 2 users, user 1 and user 2. We can see in this example the concept of non-orthogonal multiplexes. We have both work on, both use BPSK. We can see here the constellation for the first user, and here the constellation for the second user. And here we can see the 4 possible combinations. So at the reception side of U1, the U1 makes decoding of the message using the constellations in the bottom of this slide. So we have, instead of decode 2 symbols, now it decodes 4 symbols and decides which is the symbol which was submitted for him. In the next slide, we have the same scenario, but here we can see the reception for the U2 sides. I will not stay on these slides, but these slides, I saw these slides also in my class to my students. So it's from these slides you can understand how simple is the concept and how efficient is the concept, and how this concept can increase the fairness in a network and also the spectral efficiency. Okay, let's go now to the second technology component, which is the cloud radio access network. But let's see now what's happening with the energy consumption in a cellular network. This is some data from China Mobile. You know, China Mobile is the biggest operator in the world. So let's see here that what happened in the energy consumption in the cellular network on the left picture. We can see that, the major energy consumption comes from the cell site, around 72%. Also, we have some other portions of the on the energy consumption from transmission management channel, etc. Let's now focus on the energy consumption in a base station. We can see here that almost half of the energy consumption in a base station comes from the air conditioning. I'm not sure that this is well known. And the rest half comes from major equipment, such as the power amplifiers and the signal processing devices. This picture has a result to start a discussion about how to reduce the energy consumption in a base station, because some operators, as China Mobile, has more than 1 million base stations. So you can understand what's happened with the energy consumption. And the answer to this problem is the cloud radio access networks or centralized radio access networks. We call it CRAN. Okay, let's see now what is CRAN. CRAN is a new architecture that changes the traditional cellular architecture by taking advantage of cloud computing, software-defined radio, and other advanced antenna techniques. What happened? Some of the base station functionalities, I can say most of the base station functionalities, could be virtualized and pulled back to the cloud, where resources can be shared as a pool. We can see here the baseband pool. The remote radio units, the RRU, or another name is RRH, remote radio heads, which are now decoupled from the base station, can be distributed geographically to provide the required coverage. The centralized and virtualized research pool supports multi-standards and allows radio resource being shared by different radio technologies in order to improve the overall spectrum efficiency and flexibility. So CRAN is regarding now as one of the key technologies to support energy efficiency strategies in 5G networks. In the next slides, in this slide, you can see again the CRAN architecture. We can see here the CPU. CPU is in the BBU in the pool, and the pool is located at a centralized site and function, as I said before, as a cloud or data center. And the RRU units, which are connected with several ways with the BBU, with the pool. There are several ways to connect the RRU with the pool. Some of them are millimeter wave links, free space optic links, etc. Okay. What are the advantages of use CRAN as a new cellular architecture? First, as I said before, is the energy efficiency. The energy efficiency can be up to 70% of power compared to traditional radio access network, to traditional architectures. We have a reduced cost for operators on CapEx around 15% and OpEx around 50% compared to traditional architecture. We have an increased capacity, as I said before, because CRAN can implement advanced algorithms in order to mitigate intercell interference and improve spectral efficiency. For example, we can utilize the coordinated multiplane, which is a technique already used in 4G and LTE advanced in a better way. I have 5 minutes. Okay, so let's move to the last technology. The last technology is the visible light communication, or Li-Fi. Actually, this is one of our major research interests in my group, the visible light communications. And we have provided several contributions on this topic. What is visible light communication, or Li-Fi? Li-Fi actually is the commercial name of visible light communication. With visible light communication, we can utilize the LEDs, which are now for illumination, to send data indoor. Okay, we exploit the visible light spectrum, which is now, and which is not used now for data purposes. And the major advantage of using visible light communications is that we can exploit the existing infrastructure for illumination, and no extra energy is required, and we have no interference with RF. Actually, in the last 2 years, we are working on hybrid VLC and RF systems. A hybrid VLC RF means that the coexistence indoor of a Wi-Fi and the visible light systems. We have several applications.
Professor Karakyanidis, you have 2 more minutes.
2 more minutes. We have several applications for Li-Fi. We can see here. We can use Li-Fi in airports, in stadium, etc. And this is my last slide. We can see here all these technologies to work together for good. All these technologies for 5G to work together for good. We can see the massive MIMO base stations, the millimeter wave links. We can see the visible light communications indoor, and we have here. We can see here the NOMA uplink and downlink, etc. I would like to close my my talk by saying that by mentioning again that 5G is not a single standard. It is an ecosystem which includes many technologies. Most of these technologies are the research outcome from universities and research centers in the last, let's say, 15 years. And I would like to close my talk saying the quote of Kant: theory without practice is empty, and practice without theory is blind. Thank you very much.
Thank you very much, Professor Karakyanidis, for the nice talk. I'm expecting now we have time for a couple of questions through the chat, or if you wish, you can switch on your microphone and speak directly to George. So in the middle time, until the questions they will arrive, I would like to ask you, George, what about beyond 5G? I mean, what about 6G? Because, sorry about the question,
okay.
I'm coming from the area, so I'm reading just.
This is a very interesting question. You know that every 10 years we have a new generation in the wireless network. So if we reach the 6G period, it means that we are older, we are 10 years older. So really, now we have started the discussion about the 6G systems, and the major concept for 6G system is the use of artificial intelligence and machine learning in order to improve the functions of the older generations. But now we are on the discussion for the beyond 5G network, which means the networks after 2025.
Mm-hmm. And let me ask you another question. Since what about there are a lot of attendees during their applications, they are asking about the density of the antennas during the 5G. I mean, can you comment something on this?
Yes. As I showed before, one of the concepts that increases the network densification is the small cell architecture. It means that we need a dense network in order to cover the user's demands, and a dense architecture, very dense architecture, and small cell architecture means that we could have base stations very close now to the users. What does it mean, very close to the user? I think we will have we will have base stations, let's say, per floor in a building. This is an example, okay?
Mm-hmm. It reminds me the 2D materials that we are using in physics. Just to load them, we use them 2D materials in order to increase the surface to volume ratio. It reminds me something like this. We have a comment from George Milonopoulos. I'm sorry if I'm pronouncing the name wrongly. For NOMA, if we have two signals of the same frequency being transmitted simultaneously, what technique do we use to diversify them?
Okay. Actually, we use two techniques, two main techniques. One is the decoding, as I showed before, and the other is the successive interference cancellation.
Mm-hmm. Thank you very much, Professor Karagiannidis. I'm pretty sure that a lot of people, they will contact you with further questions.
Definitely.
It's an honor to have you with us. And now we move to our next speaker that comes again. It's from the academia. It's Professor Kanatas. Sorry, Thanasis, if it's Kanatas or Kanatas. I think it's Kanatas from the University of Piraeus.
Okay.
Kanatas. All right, sorry. Always I'm starting with a mistake. And he's going to speak to us about MIMO technologies for 5G communications. So Thanasis, the floor is yours, and we are looking forward to your presentation. Thank you very much. You have 20 minutes, 5 minutes before I will warn you.
Okay, so you can see the slides?
Yes.
Okay, thank you very much. Thank you, Kostas. Thank you also for the invitation to participate to this webinar. So my name is Thanasis Kanatas. I'm a professor at the Department of Digital Systems in the University of Piraeus. And I will talk about MIMO technologies, which is one of the many technology components of 5G, as said Professor Karagiannidis previously. So the topic is huge, actually, and there are thousands of papers and books published the last 25 years. I will try to keep it in less than 20 minutes time frame, and I'll try to give you the most important things to remember. So I will start with the requirements imposed by 5G systems and how the spatial domain can help to achieve these requirements. Then I will try to explain the basic idea behind MIMO techniques, multiple input, multiple output techniques. So we will discuss the single user MIMO, multi-user MIMO, massive MIMO, the millimeter wave MIMO, which is the practical means to implement the massive MIMO technique, and also the network MIMO. And I will finally provide some information on the new radio concepts related to MIMO. This is a similar slide to the one that Professor Karagiannidis showed earlier, and all the expected services that Maria Boura said, and for the next also generations of wireless systems are translated to a requirement to support a 10,000 times increase in capacity, and capacity measured in bits per second, per hertz, per square kilometer. So this figure presents the technologies that can offer in a multiplicative form this capacity. And the MIMO techniques belong to the first balloon, the orange balloon, and it is the main means to increase the spectral efficiency. The rest are the bandwidth, we need more bandwidth, and the other one is the network density, we need more base stations. So there are three main reasons to apply the multiple input, multiple output techniques, and the corresponding ways to exploit the multiple antennas and enhance the communication performance of the systems. The first one is the spatial diversity, which is used to improve the reliability of our system, to reduce the errors in our system by combating the fading. Fading is the variation of the signal power due to various phenomena in the wireless channel. The next one is the spatial multiplexing. This technique is used to increase the throughput, the data rate of the system by exploiting the multipath fading, which is the existence of several copies of the same signal that is transmitted by the transmitter, and these replicas arriving at the receiver from different directions, with different amplitude, with different delay, and possibly with different frequency due to Doppler shift. So we can transmit parallel data streams over the same resources, and this is important, and we can increase the throughput of our system. The third technique is the beamforming. Beamforming is used to improve one ratio, the ratio of the signal, the power of the signal, the wanted signal, the desired signal, to the power of the interference plus noise. And this is achieved by having the array gain, which is the gain that comes from the coherent addition of waves from many antenna elements to a specific direction. And secondly, it comes with the suppression of interference. So why MIMO systems? We use MIMO systems to increase the spectral efficiency, so more bits per second per hertz, to improve the reliability, to have less errors in our system, to suppress the channel interference, and hence we can have more users in our systems, to reduce significantly the required transmitted power. And finally, in multi-user MIMO and massive MIMO systems, we can increase the total system throughput by serving many more users in our system. So up to now, the current cellular networks up to 4G, we have single-user MIMO techniques and we have multi-user MIMO techniques. In 5G systems, we will exploit more techniques. We'll have massive MIMO, and also we'll have millimeter wave MIMO, which is a practical means, as I told you, to implement the massive MIMO technique. And also we will have what we call coordinated multi-point transmission or extended network MIMO. I will explain these techniques later on. So let's start from the single-user MIMO. In single-user MIMO, we have one transmitter and one receiver, but both have many antennas, more than one antennas. And these more antennas may be used first to give us the opportunity to improve the reliability. So we are going to exploit the concept of diversity. And a simple explanation of this idea is that at the receiver, for example, we can get independent signals, independent replicas of the transmitted signal, and then we can combine or select the best of these and get lower probability of error and thus improved reliability. So we can have more branches, as we say, more antennas, and we can get advantage of these antennas to improve, as you can see also in the figure, the probability of error. Another big, let me show you first the result of applying diversity. This is the probability of error, and it is versus the signal-to-noise ratio. The upper curve is the curve that we have in single input, single output systems, in systems that we have one antenna at the transmitter and one antenna at the receiver. If you increase the number of antennas, then you can see that you can reduce actually the probability of error. Actually, we say that we can increase the slope of the bit error rate curve. So this is really important and is one great advantage of having multiple antennas at the transmitter and or the receiver. Another big advantage of having multiple antennas at the base station and possibly at the UE is that multiple coded data streams may be transmitted in the air, and ideally we may operate further from the Shannon limit, which is applicable to CISO systems, single input, single output systems. So the important here is the multiplexing gain. What is the multiplexing gain? Is the number of parallel data streams that we can have in our system. And this multiplexing gain is limited by the number of the antennas that we have at the terminal. And this happens because we may have many antennas at the base station. And this is an example of the multiplexing gain. You can see that we have a great capacity, many bits per second per hertz, if we use many antennas at both the transmitter and the receiver. The upper curve here in this figure is an example of 4x4 system, 4 antennas at the transmitter, 4 antennas on the receiver. And the lower one curve is the CISO system, 1 antenna at the transmitter, 1 antenna at the receiver. So the advantage is great, and that's why we have used already MIMO techniques in wireless communication systems. But only lately, the mobile terminals are equipped with many antennas. So multi-user MIMO techniques is an intermediate way to increase the throughput of our system. In multi-user MIMO, the base station is equipped with many antennas, but the UEs may have just one antenna. So from the base station point of view, it is like having a single user MIMO where the antennas are not concentrated in a terminal, but are distributed in space. The multi-user MIMO techniques imply the use of what we call spatial sharing of the channel by the users. And this deeply affects the design of the multiple access protocol. It is well known that the issue in all multiple access techniques, all the protocols, is that when two or more users transmit on the same channel responses, then there is interference. So in this technique, in multi-user MIMO technique, in spatial multiple access, as we say, the resulting multi-user interference, since all transmit in the same frequency, is handled by the multiple antennas. So we have what we call the degrees of freedom, to the necessary degrees of freedom to spatially separate our users. And this is very big advantage. And therefore, there have been developed many techniques to mitigate the interference issue. Now, the multiplexing gain is the sum of the number of parallel data streams again, but now this multiplexing gain is limited by the number of the base station antennas. And the gain is mainly for the cell, is for the system, which means that we have greater capacity that can be achieved at the cell level, not for each user. Moreover, we have moved all the intelligence and all the cost of the system to the infrastructure, since the user terminals may have just one antenna. And this is really, again, very important. Now, the next technique is the massive MIMO technique, which is a novel technology that was introduced the last 10 years, initially by Thomas Marchetta. Thomas Marchetta, a distinguished researcher at Bell Labs. And the massive MIMO techniques is a way to scale up the system of antennas, a very large number of antennas at the base station. So massive MIMO means that we have a few hundred of antennas at the base station that simultaneously serve many tens of terminals in the same time frequency resource. This is really important. In this figure, an early implementation of massive MIMO antenna system is depicted by MAMOE. It's a European research project at sub-6 gigahertz frequency band. So what is massive MIMO? Massive MIMO is a form of multi-user MIMO, but now we have a very large number of antennas at the base station, much larger than the number of devices that are served per signaling resource. So this great difference in the number of antennas results in what we call asymptotic channel orthogonality, which means that the channel responses among the users and the base stations are quasi-orthogonal. And this gives us the potential to have huge gains in spectral efficiency, since many users may use the same resources without interference. Sorry. Okay, one of the main now advantages of massive MIMO is the spatial focusing. An example is shown in this figure. At the left, we have the energy transmitted by a system, and we depict the energy in a field of 10 lambda by 10 lambda, as you can see. The transmitting antenna is a linear array, a uniform linear array with 10 elements. And on the right side of the picture, you can see the same the energy again in the same field, but with 100 antenna elements. You can observe that we have a concentration of the energy at the center of the area. This clearly depicts the capabilities of massive MIMO system to produce beams, to produce narrow beams, to produce what we say to beam forming. Now, as I initially explained, we will need more bandwidth to achieve big data rates, and there is plenty of such bandwidth available above 3 gigahertz. Actually, we're going to use 28 gigahertz band and 38 gigahertz band, and later on we may use also 60 giga frequency band, since there is available bandwidth there. The increased data rate is the main reason for using the millimeter waves. As you can see from this figure, at millimeter waves, we can achieve great data rates. You can see 5 to 20 gigabits per second, but at the expense of coverage. Another important observation from this figure is that the 5G coverage at 3.5 giga may be similar to that of LTE 1800 if we use massive MIMO beamforming. So massive MIMO beamforming can be implemented with millimeter wave MIMO. It is more practical to use millimeter waves to implement the massive MIMO. So it is the practical way to implement massive MIMO system with large number of antennas. And this may happen due to the increased frequency and hence the reduced wavelength. One should bear in mind that the dimensions of an antenna are analogous to the wavelength. So if you reduce the wavelength, increase the frequency, then you can reduce the size of the antenna, and therefore you can have more antennas installed in a small practical area at the base station, but also at the user equipment, at the user terminals.
And
so,
5 more minutes.
Okay, thank you. So the beamforming is a technique that was also implemented in 4G networks, especially in the azimuth domain. What we can achieve with millimeter wave MIMO systems is highly directional transmissions to specific users, as you can see from this figure. How do we implement these beams? We use multiple antennas that are fed with different amplitude and phases, with appropriate amplitude and phases. So we can have purely analog or purely digital or hybrid techniques, hybrid beamforming techniques. And this means that we can use either phase shifters and power amplifiers at the RF level, or you can have pure imaginary weights at baseband level, or you can have a combination of both. The computations involved in such a system, in such a hybrid system, for example, are highly complex. And for this reason, lately, AI algorithms, AI techniques, artificial intelligence techniques may be used and have been used to solve this complex problem of finding the appropriate weights in analog and digital domain. Now, the novel thing in 5G networks with the millimeter wave massive MIMO techniques is that we can have beamforming in azimuth and elevation, which means, as you can see from the figure, that the base station will have the capability to focus to specific users wherever they are located, in a lower level or a higher level in a high building. Finally, this network MIMO technique, the coordinated multi-point transmission technique, can be considered as a large-scale MIMO system with several distributed antenna groups. We have coordinated transmission from multiple base stations to their terminals, to their UEs, and there is this is effective, really effective in mitigating the interference in multi-cell systems. Actually, we can have several base stations that cooperate to jointly optimize the resource allocation from a global, rather a local perspective, which is a small cell. So the new radio standards have introduced many novel things for MIMO techniques. At sub-6 gigahertz band, we have many refinements and enhancements related to 4G systems. So we have more detailed feedback for channel state information, or we have many more multi-user MIMO layers to enhance the data rate. And also at millimeter wave band, the main issue is the path loss and consequently the coverage of the system. So beamforming is the main tool to overcome the issue. What are the novel beamforming techniques in 5G? First of all, we can have beamforming not only for the data, which was already applied to 4G systems, but also to control edge broadcast signals, and this is a big difference. And also we may have beamforming on the uplink. So the UE may have many antennas and can perform beamforming in the uplink, mainly analog. So new radio supports analog beamforming and also a new framework for beam management. Now, since the millimeter wave band is unpaired for 5G systems, the duplexing method that we use is the time division duplexing, which means that we use the same frequency for the uplink and the downlink for one user. And this is really helpful since we have reciprocal, as we say, channels. As I told you, the topic is huge. A lot of technical info is available, and all companies provide their solutions to the MIMO related issues. I think that I took advantage of the whole 20 minutes period. Thank you very much, and I'm here for questions.
Thank you very much, Thanasis, for the enthusiasm, also of the nice presentation. We have already one question from the audience through the chat. Do you think that artificial intelligence ML algorithms can be used in MIMO 5G systems for channel allocation and or power control, and in what way?
Sorry, I missed it.
All right, sorry. Probably you have Yanis Bartsiokas. Are you with us? Yanis? Okay. I mean, he has sent the question through the chat. And the question...
Can you repeat it, please, because I missed it.
Yeah, I will repeat it. Do you think that
Yes.
artificial intelligence, ML algos, can be used in MIMO 5G systems for channel allocation and or power control, and in what way?
Artificial intelligence will be used for MIMO systems for sure, and machine learning is already used. Mainly will be used in beamforming. Will be used, as I told you, to select initially the amplitude and the phase of the different elements. Now, artificial intelligence is a tool, is an optimization tool for us. So you can imagine of many applications, and also other applications in MIMO systems. Yes, it can be used also for many things that you want to optimize, is the answer.
Any other question? Thanks a lot from Yanis. He's very satisfied with your answer. Can you please repeat what is the difference between 4 and 5G MIMOs?
In 4G MIMOs, we have only single user MIMO and multi-user MIMO. It is the first time that we have massive MIMO and millimeter wave MIMO. So it is really the first time that we apply these techniques in our network. So we may have much more increased capacity and reduced errors, increased reliability.
Thank you very much, Thanasis, for the nice presentation. I think that we should move to the next one. All the presentations, they will be uploaded into our YouTube channel, and I will send to all participants the link. So the next speaker comes from the industry. So we have industry to academics, and now industry again. Comes from Denmark, from the provider over there. It's Hans Henrik Bank, and he will speak to us, and I'm pretty sure that he's going to convince us that 5G is a game changer. So the floor is yours, Hans. Thank you very much to be with us, and you have 20 minutes.
Thank you very much for inviting me. I hope you can hear me.
Yes, we can hear you very well.
Yes, and I'll share my presentation. Let me just introduce myself. My name is Hans Henrik Bang. I'm an engineer from a background, and I'm a senior director in TDC Net, which is the largest telco in Denmark. basically providing network services, both mobile and fixed network.
Probably, Hans, probably you can, yes, thank you.
There we go. Okay, so first a little quiz question for you. Now you probably can't answer since this is a webinar, but the question is, how much of the world's online data has been created within the last 2 years? So just take a guess, think within your head, how many percent do you think? And I'll give you 5 seconds to think of a number. And then I'll give you the answer. It's 90%. So this is just, it's a good illustration of what's going on in the world today, that there is a lot of data being generated and we need to be able to transmit that data. I'll just give you a little background first about what we've been doing in Denmark in the industry, in TDC Net first, and then I'll get back to what we're going to use 5G for. We did activate our 5G network on September 7th, 2020, so it's quite new. It's only a little over a month. It has only been up for about a month. And we're basically doing it by swapping out our entire network. We came from a Huawei network that was brand new in 2013. We built the whole network then, and now we are swapping out the entire network, and you can just see it here. Basically, this was September 1st, just before we activated the network, and the blue areas is Ericsson 5G radio equipment, and the red stuff is Huawei equipment. So this was September 1st, and then October 1st, this is where we are now. And November 1st, we predict that this is where we're going to be. And by December 1st, we're going to cover the entire country with approximately 95% of 5G coverage. So that's just what we've been doing in Denmark. A little bit about the network we're building. And my title is How This is Going to Change Society. And the short answer is actually, I don't know. And you might say, why don't I know if I'm here presenting it? And my point is that I don't think anybody here really knows it. Just to give you an analogy, if you think back to, if you're old enough to remember SMSs, when we got those back in the 1990s, SMS was originally thought as a short messaging service and was meant for operators to be able to send text messages to the customers, saying your bill was overdue or something like that. But then somebody came up with the idea that you could send SMSs to each other as well, to send short messages to each other. And that took off like, well, you know that, and turned into the whole messaging revolution. So it came from basically a very simple piece of technology, and the use cases were just enormous on how could you actually use this on the other side that nobody who invented the technology actually thought about. So that's really my point, that I'll give you some indications of what this can be used for, but I don't think we've seen the full potential, and I don't think anybody really knows it because we just provide the technology. What we're doing is that we believe we're building the network for the future. So we partnered up with Ericsson. Ericsson is both providing the technology and providing the managed service. So they operate our mobile network. And we're basically upgrading the whole of the mobile core. We also have an IMS core that is being virtualized, and we're swapping out the entire RAN. So that's approximately 3,800 sites that are being swapped from Huawei equipment to Ericsson. That already gives us some large 4G improvements, some speed improvements, or a factor 2 to 3. And the 5G national coverage that will be achieved around December 1st. And we do it to retain our position as Denmark's best network. We're basically running a competition every year to see who has the best network in Denmark. We are 3 independent operators. Let me just see if I can move. I just need to move this one out of the way. There we go. We are doing managed service with Ericsson, so they're running our network, and I just want to show you what we intend to do with swapping the mobile RAN. We get 2 to 3 times the throughput on 4G, and we've actually demonstrated a throughput of more than 2 gigabit per second on 5G. Of course, that will not be the experience of the average user, but that's in best circumstances when you have plenty of spectrum available and so on. We are expecting to see an explosion in the number of IoT devices. So that's also part of what we're doing with 5G. We are building a completely new IoT core that will enable us to attach billions of devices to our network. You can see on the left side of the screen, you can basically see a projection of the number of connected devices we expect to see in the network worldwide from 2015 to 2025. And just a few examples on the right side. I'm not going to go through all of them, but there are both examples of high data usage and a lot of low data rate applications such as wearables, tracking assets. We're already seeing that with a lot of industries wanting to track their assets if they're stolen or they just can't find them and want to get their location. You can do a lot of measurements. Some of the more interesting applications is actually in agriculture. We're partnering up with someone putting IoT devices into cows. And I didn't bring one with me, but it's sort of a plastic container about this size. And you basically feed it to the cow. And due to its size, it will go to stomach number 2, I think it is, in the cow. And from there, it'll be able to transmit a lot of data about where the cow is, the temperature, and so on. So a lot of information, vital information about the cow can be transmitted. And this device can retain battery for approximately 10 years. So it's pretty much for the lifetime of a cow. You can use this technology to monitor the cow. So what are we going to use 5G for? And as I said before, we don't really know. We have some good ideas, of course. And one of the things we're doing in order to maximize our 5G investment is that we've set up something we called an innovation hub. So that's TDC Net, my company, and Ericsson, our technology provider. We made this joint 5G innovation hub, which consists of 7 people, both business experts and technical experts. And their job is basically to maximize the investment and interface as much as possible with the outside world to make sure that we partner up with external partners that want to try something with our 5G network. I'll get back to some actual use cases later in the presentation. So what we already have now in 2020, we have a 5G core. So we have 5G mobile broadband. We can do Internet of Things tracking and video, and we are looking into a pilot of fixed wireless access. It's one of the interesting applications of 5G, where using either 3.5 gigahertz or millimeter wave, you can get up to quite high bandwidths, sort of fiber-like speeds, which can be very interesting, especially in more rural areas where fiber investment is just not realistic. So we can serve a lot of households that maybe currently are on a low DSL connection, low band DSL connection, and we will be able to serve them with a fixed wireless access. It's something we're doing a pilot with starting the beginning of next year, and we just picked a few areas and we'll see how that works. Coming in 2022, we'll get 5G slicing. I'll get back to that in a little bit. We'll get ultra low latency, ultra high reliability, massive IoT, and also sustainability. One of the interesting things about 5G is that it actually takes about an order of magnitude less power to produce a bit in 5G than it does on previous technologies. And that's, of course, due to much higher bandwidth. So in terms of power usage, you can actually transmit the same amount of data with much less power usage. Of course, the actual usage is going up by approximately 40% year over year in our network. So it translates both into maybe some power savings, but also the ability to transmit a lot more data. So what we're achieving with our 5G Innovation Hub is we get a knowledge center in Scandinavia. We're quite close to Lund, which is in Sweden, where Ericsson has a research lab. We're trying to build a very innovative 5G roadmap, a little bit like you see here, but just much more detailed. What do we see is coming? And we keep that updated between Ericsson and ourselves and industry partners. We want to show value of 5G beyond connectivity via proof of concepts. So we're basically, with the Innovation Hub, we're building actual proof of concepts, doing things live. And I'll get back to a few examples. We want to drive the 5G agenda in Denmark and share knowledge both internally and externally. So we're quite open for discussing with partners. So what does 5G give us in the future? You've probably seen a lot of the applications, but I just want to get into a little bit more into some of them. This is 5G, and I just put in 4G as well, because of course 5G is not something completely different. We're just basically moving the triangle to the right because we get a lot more of everything. And you might know the 5G triangle already. Basically, there are 3 main selling points in 5G. The one is higher speed, which gives us higher capacity. And we have the next one, which is many more attached devices, going back to the IoT agenda. And the third one is low latency and high reliability. So the time it takes for a data packet to go from the sender to the receiver and get an answer back again, which is very important for some applications. And as you can see, there's a lot of application already like 4K streaming. You can do that on 4K. So why do you want to do it on 5G? Sorry. But it's both a bandwidth issue, and there is application that can be that really can only be done in 5G. For example, if you go up to 3D video, if you go up to 8K streaming, if you do 360 degree 4K video, free viewpoint video. And also there is quite a movement to work and play in the cloud. You've probably seen some of the game services already, moving games into the cloud. So your terminal can basically be a dumb device where all the computing power takes place in the cloud instead. I think that can be quite important for mobile applications, because you can save a lot of battery by getting the processing done in the cloud and then save power on your device. But that needs a lot of bandwidth, and it also needs very low latency. If you're playing a game, you don't really want to even miss 50, 100 milliseconds when you're playing. That will just make the game unplayable. There is also a large use case in augmented and virtual reality. Depending on where you have the processing power, you can have it locally, or you can again have it in the cloud. And if you do have it in the cloud, then it requires very low latency, because if you tried virtual reality, you will know that latency is really a killer in terms of if the image doesn't move exactly when you move your head, then you will get nausea within a very short time. We do see some very interesting applications in mission critical applications. So that's police, ambulances, and so on, from the use of slicing. I'll get back to that in a little bit, but basically slicing is that you can reserve part of the spectrum or part of the bandwidth really for special applications. So you can imagine a football stadium which is full of people streaming video and using their mobile phones for a lot of things. And if you experience that today, very often you will experience congestion, and you can't really stream anything because there are so many users loading the mobile network at the same time. If you do use slicing, you could imagine you have an ambulance that is using its own slice of the network. So we basically have reserved bandwidth under certain parameters in the network, making sure that even though they're driving right past the stadium with the 50,000 people in it, they have sufficient bandwidth to maybe hook up with a doctor, get first treatment for the passengers. So this can potentially be a lifesaver. We can also use industrial automation. We do have a partnership currently with a large Danish industrial company called Grundfos. I'll get back to that in a second. But that's one of the very interesting applications we see, and we get a lot of interest from industry players because we can basically create very, very low latency networks and very, very high reliability. Last application I mentioned here is self-driving cars, especially here is low latency is key again, because if you do have a situation evolving, you don't really want to spend seconds having your data traveling back and forth before the car decides that it needs to swerve or brake or whatever you want to do. So this is a bit of what some of the applications for the future in 5G can be. If I dive a little bit more into slicing and private networks as such, then we see basically three versions of having private networks. And the one to the left is slicing, the one I briefly mentioned before, which is basically us as a telco operator providing a slice for a customer. And that gives you a reserved bandwidth, so you can basically set the parameters. I want to have this much throughput, I want to have this quality of service, I want to have this latency, and then we can set that and reserve it in the network to make sure that this is guaranteed. You always get this bandwidth and these parameters, no matter what the load is in the network. And it does sound simple, and it's actually also possible to do on 4G already. We have done some simple slicing applications, but that's using dedicated hardware, and it's very complicated to set up. One of the great advantages of using slicing in 5G is that you can orchestrate it, meaning that you can really set up a slice in 20 minutes using pretty much standard software. So it's almost, you can basically, I can imagine you push the technology to the customer, and you can almost go to a web page, our web page, and order your own slice of the network. Just set the parameters you want to do, put it in the basket, click on checkout, and voila, you have your own 5G network and a slice. And of course, you pay according to the parameters you set. If you have if your demands are bigger, then you can do a hybrid network. You might, for example, be an industry where you require that your data does not leave the premises. So in that case, you can have a core at your site, or you can have some kind of edge computing where you basically push computing power close to your site, and that will give you local data. It will also give you better latency because there is a shorter distance to reach the computing node. And the alternative on the right with a dedicated private network, that's basically the ultimate version where you have both your own computing power locally, and you also have a local base station to ensure that you have the very lowest latency, and you also have completely private communication. Sorry? Okay, just to finish with 3 actual use cases we've seen. First one is augmented reality. I mentioned it a little bit before. We did a test with testing HoloLenses. So this girl is wearing a HoloLens and doing a Teams meeting in the middle of Copenhagen. And we did this connecting via a smartphone on 5G. We used a 5G Wi-Fi router, and then we also tried on normal Wi-Fi and 4G. And the experience here was that we actually had a tester with NNIT, and his comment was that the TDCnet 5G gave a markedly improved user experience when using the HoloLens, so compared to using it, for example, on Wi-Fi or on 5G. So there's a clear gain. We've also seen an interesting application with realtors when they sell the apartments. You can also wear some augmented reality goggles, and then you can go into an unfurnished apartment if it's brand new, and you can basically furnish it yourself. So you can, using gestures, you can take a couch and a table and just put it out in front of you and see it as this is what it looks like. And again, that's something that requires very low latency, or you will get very nauseated very quickly. To show you a second application, that's back to the Innovation Hub. We're doing a partnership with Grundfos, and they're a large industrial player in Denmark, and they have been looking into basically turning their whole production into a wireless production. They're already using Wi-Fi, but they have a lot of complaints about Wi-Fi. It's not really stable enough. It's prone to interference. And but it's very important for them to be able to move their machinery, their robots around, so they don't want to be attached to any cables. So they see 5G as the ultimate solution to get out of the wired environment and get out of the quite unstable Wi-Fi environment, and use 5G in order to make their all their production connected and reliable. So this is something we see there is potentially a huge demand for, pushing 5G technology in various degrees of private networks, as you could see before, into the industry. The last use case I want to share with you is actually an illustration of what I said in the beginning, that nobody really knows what this is going to be used for, because this one came from a very interesting partnership we have with a Danish TV station. So we have this Danish TV station called TV2, and they are really keen on using our new technology, because they came from having huge satellite trucks whenever they had to do presentations from somewhere. When we started rolling out 4G, we did a partnership, and they could bundle up 8 4G subscriptions in order to do broadcast quality TV from anywhere. But that was more of an experiment. But with using 5G, they came up with a totally novel use case that I wouldn't have thought of in a million years. And that's basically my point here, because if you remember the 5G triangle, with the 5G bringing millions of devices and much higher speed and lower latency, that's really what we provide as a network operator. But then the use cases on top, there's a lot of industry players and a lot of people, creative people, coming up with ideas that we have never thought of. And they came up with this one, which I thought was really brilliant, and I never thought of it before. The point is basically that once you have the bandwidth and the speed and the low latency, they said they could do production, so TV production of smaller sporting events. Of course, they already do soccer games and large sporting events, but currently that requires several camera people being on the location, and they track the camera around, and there's a producer producing the show and so on. But using remote cameras, like the one showed on the left, you can basically have a smaller sporting event, just put up 5, or how many you need, remote controlled cameras. You connect them via 5G to the cloud, and you can have some cloud computing and some artificial intelligence that can control the cameras, so it can decide, here is the ball, this player has an interesting face, and so on. So you will have the cameras tracking this remotely, and it requires 5G because it requires very low latency in order to follow the ball and so on. So it's really, that is really key to do this. But the point is that you can actually, with maybe one human producer, you can almost auto-produce a show, just have one producer monitor the production, and then stream it to users. So that opens up a whole new niche for smaller sporting events that are currently really not feasible to do TV coverage because it's too expensive. But once you have the right technology with remote control cameras and 5G connectivity, then you can start seeing events like this that you hadn't thought of before. And if you should remember one thing from my presentation, that's really this, that nobody really knows what 5G will bring, because we only provide the network and the basic parameters, the technological parameters, but the interesting use cases will come when users figure out what can we actually use these new technical parameters for. So that's the conclusion of my presentation.
Thank you, Hans. Thank you very much for keeping the time as the previous speakers. This is very important. We have a couple of questions. The first one is the following. Everything being on the cloud means that the users will save space and data or not?
I imagine they will save space on their devices. So as they already do, a lot of people use OneDrive and so on to store all their data in the cloud, which has several advantages from backup and so on. So they will definitely save space if that's what you mean, space on your device. I certainly see they will save that, and it will end up in the data centers instead. Actually, I heard an interesting quote from Huawei a couple of years ago. If you think back to a famous quote from, I think it was the 50s, the director of Digital Corporation, he said that he thought there would be a demand for about 5 computers worldwide. And he thought that in the 50s. And of course, he was the laughing stock for about 50 years, because then the PC revolution came up and there were billions of computers. But a few years ago, the director of Huawei said that he believed that in the future, there would be around 5 clouds in the world. So actually, Digital's director may have been right anyway. He was just sort of 70 years too early, because a lot of the computing power might end up in the cloud, and you will just have devices that are really dumb devices with not much space, but attached via a very fast connectivity to a cloud.
Thank you. The second question is the following. Which spectrum in 5G is used while using IR and VR technology? Virtual reality, and the other one is the one that you have already mentioned. And what speeds are required to have these technologies working? Yes, and I have a question myself on top of this. Is like, so virtual reality can be supported by 5G technology?
What was the last question? Which VR technology?
If the virtual reality can be supported by the 5G.
Mm-hmm. Okay, first the spectrum. We have rolled out 2 versions, or currently we're using 2 spectrum. We're using 700 megahertz and we're using 3.5 gigahertz. And 3.5 gigahertz definitely offers the highest bandwidth. That's where we reach the 2 gigabit per second, is actually 3.5 gigahertz, and also using several other bands at the same time to achieve the maximum bandwidth. So in order to get the real low latency and the high bandwidth, you do need 3.5 gigahertz.
Thank you very much. Okay, go on.
Yeah, and virtual reality, I'm not quite sure about the bitrate that would be needed, but I think it's in terms of video, it's basically streaming 2 high resolution images to you. So in terms of bandwidth, it's not that high. We're looking into something like 15, 20 megabit per second. The really important issue is actually the latency, because the delay is a real killer. If there is just a very short delay, you'll get very nauseated, because you will see the image lagging behind what you're seeing as soon as you have the processing power in the cloud.
Thank you, Hans. I would like to excuse myself from the rest of the attendees that they have more questions. I will forward all the questions to Hans, because I have to move to the next speaker. The next speaker comes from the consulting world, from Accenture. He's a senior manager over there, and also he's a great fan of basketball, of Panathinaikos Basketball Club. So we have some basketball fans among us, Vangelis from Barcelona and from Canaria. So it's a great pleasure to have with us Vangelis Karelis. Vangelis, Accenture recently has released a very nice report about 5G in Greece. So there are a lot of questions, Vangelis. What about the developments of 5G network and technology within our country. The floor is yours, and thank you very much.
Let me share my screen first of all.
Yes.
I hope that can you hear me okay?
Yeah, we can hear you very well. Please share your screen.
I'm already sharing. Can you see?
Not yet.
Stop sharing. Here. I need to hold on a second. Share screen.
Yes, now it's fantastic. Thank you.
Okay. Just a second, it's not full screen yet. Okay. Thank you, Konstantinos, for the kind introduction. Good morning to all the people in the webinar today. I'm extremely happy and that I will have the opportunity to present the result of our research study today, Fuel for Innovation, Greece's Race to 5G, in this audience. Technology is bringing us all together, and I'm extremely satisfied to see how easy we can gather so many people and exchange information and ideas about a very pioneer topic, and which is discussed at the moment in various tables and among a lot of companies and partners. To start with, from the launch of the first 5G devices and trials and commercial services, 2019 and 20 has been the year 5G truly caught hold of the public attention. And over the next decade and beyond, we will continue to see consumer, businesses, the economic and society transformed by the 5G technologies and capabilities. Having in mind the above, as already Konstantinos introduced, we decided to conduct a study exclusively for Greece. Greece's race to 5G is aiming to provide strong evidence that 5G can play a fundamental role in unlocking trapped value in Greece, both for businesses, state, and society. We attempted to answer a series of critical questions regarding Greece's 5G future, such as, are we ready to design the path to 5G? Is there a market demand? What is the Greek industry's readiness for 5G adoption? What will be the first industry use cases that will materialize the expected benefits of 5G capabilities? What will be the economic impact for the Greek economy and society by embracing the 5G adoption? Regarding the existing status of Greece towards 5G, the implementation of pilot programs by the telecom operators in specific sectors has been a positive development. As you all know, Greece is expected to complete the auction of 5G spectrum by the end of the year, which will possibly affect Greece's ranking in the Digital Economy and Society Index, the well-known to all of us DESI. Unfortunately, in the recent ranking, Greece occupied the second last position among the EU countries. Our study demonstrates in the most emphatic way that there is a momentum for the development and promotion of 5G in Greece. We therefore believe that the conclusion of our research will be a useful guide for the 5G future of our country, available to all business leaders and institutions. The first topic we need to elaborate is what the advent of 5G will mean in our lives. Already the concept explained extremely well by many presenters, so I will make just a few remarks. 5G represents the next generation of mobile communication, which is expected to offer a revolutionary improvement in three major areas. The triangle already presented many times, I see today. The dramatic increase in internet browsing speeds, the achievement of extremely low latency communication, and the radical increase in the number of interconnected devices. 5G is a network of networks that will be able to connect consumer, businesses, devices, and public services. As it is shown on the slide, 5G will better connect the whole world. It does not therefore represent a simple evolution or marginal improvement of 3G or 4G, but a fundamental transformation of the role that mobile communication will be required to play in every aspect of our personal, professional, and social existence. In this context, we designed and implemented a holistic approach to deliver our study. Specifically, we took into account the point of views and expectation of the Greek consumer public regarding the changes that 5G will bring to people's life. We recorded the estimates and forecast of telecommunication providers who will be the ones that will have the responsibility to offer us 5G services, while we also capture the view of the Greek business world around how they look forward to the adoption of 5G solution. Our goal was to address both the demand side of new products and services promised by the 5th generation of networks at the level of consumer and businesses of all sectors, but also the supply side. So the telecommunication providers who will make these products available and services through the development and upgrade of their networks. In addition, we met with important leaders of institutions such as the Ministry of Digital Governance, SEV, to include in our analysis their own perspective on the evolution of 5G in Greece. At the same time, we gather additional data that demonstrate the significant influence that 5G is expected to have in areas of key importance for the Greek economy, and we capture the impact that it will have on the Greek economy in terms of GDP growth and employment. Finally, we identified a number of important initiatives that, if taken in time, are expected to accelerate the introduction of 5G in the country. I will summarize today to you the main findings per area. So, starting from the recording and analysis of the Greek public opinion about 5G, we asked 600 inhabitants of all ages, gender, income, and education level from all over Greece, and discovered some very important findings, which we consider they need a special reference. In particular, as we get closer and closer to the upcoming 5G era, the familiarity with the new technology is very high, 92%, especially in the younger and more educated audiences. Another 75% of respondents agree that it is important for Greece to be among the countries that will play a leading role in the adoption and promotion of 5G in Southeast Europe. In addition, the enthusiasm and optimism for the upcoming 5G era is at higher level among the younger generation and people with a higher level of education. 5G is expected to heavily affect us in the field of entertainment as well as in our professional daily life through a series of innovative and radical applications. The key question therefore emerges: which applications are going to attract the interest of the Greek consumers? To this important question, the people answered that coverage is in rural areas, real-time language translation, the development of remote health services, the use of augmented reality in education, seamless 4K or 8K video streaming, and development of smart cities are climbing to the top of their preferences and will be in great demand. The digitalization of the state also has a high response rate, a finding that the recent pandemic crisis has made more relevant than ever. We also consider important to look at those factors that influence citizens in terms of their fixed and mobile communication. So regardless of the type of communication, wireless or wired, the respondents express concerns about the high monthly cost and secondarily about the slow internet speed and security issues. Safety is emerging as an important factor among people with a higher level of education. Factors that will trigger the consumer public to turn to 5G is definitely a crucial topic. Speeds of 1 to 10 Gbps on the internet and combined mobile home broadband bill at a lower bundle price are the main motivation for switching to 5G according to our sample. I would like now to emphasize on a question I'm sure everybody would like to know the answer. Will the Greek consumer public pay to enjoy services and applications that will be possible with 5G? And if so, how much more than today? I think you will find our conclusion very interesting. Although high monthly costs are perceived as a major obstacle towards 5G adoption, consumers are willing to pay to get 5G services, 43%. 43% of respondents tend to pay up to 10 euros more than the cost of fixed landline services for 5G, while 40% of respondents tend to pay up to 10 euros more than the cost of mobile services for 5G. People aged 18 to 34 years old are more willing to pay to get 5G services. However, we must acknowledge that 5G does not seem to be an immediate need and a top priority. Almost half of the respondents, 48%, agree to suspend the transition to 5G until they receive feedback from other users, while 1/3 of the population will not buy 5G service until their general adoption is done. We should note that early 5G users were only 3% of our sample. Finally, on the issue of the main obstacles that 5G will have to overcome, the high monthly fees, the cost of acquisition of acquiring smartphones, and the health risk due to electromagnetic radiation are considered of high importance. Let me outline at this point that the younger generation are mainly concerned about the high monthly bill cost and acquisition cost of devices, while the older ones are mainly concerned about the possible impact of 5G on the quality of public health. We strongly believe that one of the most interesting areas of our study is the view of the Greek business world in relation to what they know and expect from 5G. As already mentioned, the advent of 5G promises to bring unprecedented network speeds combined with high flexibility and reliability. But what does this really mean, for example, for the industrial sector, the tourist sector, the health sector, and of course, all other sectors of the Greek economy? Towards that direction, we conducted an online survey, which was answered by 245 companies in 13 different industries. The sample represents more than 30% of the country's GDP, and those companies employing about 275,000 people. It is important to point out that the answers we receive are about company strategies and not opinions from individual executives. We also held some one-to-one discussion with a number of companies. The study revealed very interesting findings, the most important of which I will mention immediately. Specifically, the level of knowledge of Greek companies regarding the future of 5G is extremely high, while their executives recognize that this technology has significant competitive advantages. In this context, companies believe that with 5G, they will be able to develop applications that will save them valuable time from their work, will deal with previously unresolved issues, and will gain competitive advantage over their competitors. A very interesting parameter is that 36 companies from 10 different industries intend to take advantage of the capabilities of 5G to create private campus networks. However, 8 out of 10 companies stated that they need support in order to perceive and envision possible 5G application and implementation in their businesses. These findings suggest that while industries are aware of the importance of 5G, they have not yet fully crystallized how this will change their strategic or business model and help them upgrade their products and the way they work. At the same time, the study revealed a relatively uncertainty about 5G, as only 44% of businesses ultimately believe in achieving the dramatically improved speeds promised by 5G. We also asked the enterprises about its estimation related to the degree of adoption of 5G application by 2025 in Greece. Some of their indicative predictions that need to be mentioned are that 2/3 of our sample believe that 5G will contribute to the formation of a safer working environment in the industrial sector, while 57% believe that the improvement of health services provided to citizens will be favored. Almost 1 in 2 companies predict that within the next 5 years, 5G will make the cities we live in more intelligent. To the positive opinions gathered for 5G, it is added the almost universal view, 92%, that with the 5th generation of communication, we will be connected to the whole range of our activities. Through the fast exchange of data in almost real time, 82% believe that the introduction of robots in the production lines of all companies belonging to the family of Industry 4.0 or Industry X, as we call in Accenture, will provide greater efficiency. New and promising technologies such as the Internet of Things, artificial intelligence, and robotics are expected to have a decisive impact and be massively implemented by a very wide range of businesses across all sectors. We must also underline the fact that companies recognize the social benefits that 5G will bring, as 75% of our sample believes that this new technology will benefit all citizens and not just the ones who have a smartphone. A very interesting finding is associated with the role of ecosystem. I think that already mentioned multiple times by the previous speakers. Ecosystem in promoting and adopting 5G solution, given that 57% of the companies that respond to our survey are positive about the prospect of creating a 5G ecosystem within its own industry. In addition, regarding the upcoming partnership for the development of 5G-based solution, 54% of respondents stated that they intend to work with system integrators, 30% with telecommunication providers, and 15% with consulting companies in order to acquire 5G services and applications. Our study also aimed to record and classify barriers to 5G adoption. In particular, the total cost of investing in 5G emerged by 51% of companies as a top obstacle that could slow down 5G integration, followed by a lack of knowledge, as I said before, and lack of knowledge of how to use it and the security concern. Interpreting this finding, we believe that the real concern of companies is not the amount of investment per se, but whether this investment has a high return multiplier and is justified in terms of benefits, financial or not, that it will offer. So they are concerned about the return of investment. Of particular importance in our study is the recording of application, as indicated by the companies through 5G survey that was done. The range of answers we gathered demonstrate in the most tangible way the impact that 5G is expected to have in almost every sector of the Greek economy. And let me highlight here that these use cases are coming really from the companies. It is not like a generic survey. In particular, companies operating in the industry and the production of goods seek to develop solutions for the automation of their production line using interconnected robots and autonomous vehicles, monitoring their warehouse, improving security in the workplace through the installation of smart sensors, updating their application in real time, and enhancing remote working. The energy industry will seek to develop Internet of Things-based solutions to create smart power distribution networks, while the agriculture sector will rely on drones and intelligence sensors to improve its productivity and efficiency. Retail companies will rely on AR, VR applications to enhance the consumer experience when choosing and purchasing a good. High-tech companies have stated that they are positive about creating private campus networks and developing applications using artificial intelligence. The healthcare industry expects that 5G will facilitate the provision of remote health services and remote surgery. Shipping sector is seeking to use drones for air checks and inspection, while they intend to leverage 5G for flexible remote working as well as enhance work safety. The education sector expects that 5G will simplify distance learning and training, as well as the possibility of real-time monitoring of school bus routes. In addition, the tourist industry aims to improve the connectivity services it will offer to visitors to monitor the health status of tourists, as well as to improve the travel tourist experience with the help of artificial intelligence. Finally, the financial and insurance sector believes that 5G will make it more possible to exchange information and data in real time with its customers. Then, recognizing the key role of telecommunication providers in the development and adoption of 5G and its application in our country, we try to discover their intention and strategic plans through interviews with C-level executives and the completion of a relevant questionnaires. First of all, the crucial question that often concerns us regarding 5G is when the services will be commercially available. I see also this question was in the chat some minutes ago. This question is directly related to the construction of the respective network infrastructure. So for Greece, 2 out of 4 providers estimated that 5th generation networks will be available in 2021. All telco providers agree that enhanced mobile broadband will be among the first commercially available 5G services. An important aspect, which may significantly shorten the time required to develop a 5G network, is the cooperation and coordination of providers for network deployment, a practice that has been fully adopted in a variety of European and non-European countries. All providers in Greece were positive about the possibility of cooperation, without this indicating that they would have reached their final decision on this topic. In addition, there is a consensus among all of them that the simplification of existing bureaucratic procedures for the licensing of the new antennas and base station, in combination with the total cost of spectrum acquisition, constitutes the 2 initiatives to be evaluated by relevant institutions. Last but not least, the security issues are highlighted by almost all providers as the biggest technical challenge they will face on the way to 5G. A notable difference between 5G and previous generation of mobile communication is the ability for providers to play a broader role than the connectivity provider and invest in verticals that will be heavily benefited by 5G. Initially, all 4 local telecom providers consider enhancing the end customer experience as the main reason for the development of 5th generation networks, followed by addressing the capacity needs of their networks. 2 of the 4 also mentioned the provision of fixed wireless access as a reason for next generation networks. At this point, it is worth noting that 3 out of 4 providers will focus on tourism sector, while 2 out of 4 will focus on industry, manufacturing, energy, and comms and media in order to promote interconnected solutions and applications that will become a reality within 5G. At the same time, they pointed out to us that mobile gaming can benefit the most from the advent of 5G. The providers also believe that the possibilities offered by augmented reality and virtual reality application in combination with edge computing will be a pole of attraction for the above mentioned sectors, especially for AR and VR. They argue that it will bring revolutionary changes in the field of education. Finally, we observe full convergence between providers on the fact that the ultra-reliable low latency is the main differentiator compared to previous generation of mobile communication. Reflecting on the views of telco operators regarding the creation of new revenue streams, all 4 providers looking forward to the creation and offer of new services, as well as the establishment of partnerships through the new business models. At the same time, 3 out of 4 providers recognize the formation of commercial agreements with guarantee SLAs as the main business model for B2B monetization. In conclusion, telecoms are aligned that the readiness of their industry for the upcoming 5G era is high, given the corresponding pilot trial programs that took place, and even higher compared to the transition from 3G to 4G almost a decade ago. After having a complete picture regarding the views and assessment of all stakeholders on the future of 5G in our country, we decided to quantify the economic impact of 5G in Greece in terms of GDP growth and stimulus of employment. That is why, in collaboration with the Accenture research team, we have developed an advanced econometric model that calculates for each European country member state the impact of 5G and on its real economy. Accenture econometric model estimates that the adoption of 5G in Greece will increase GDP by $4.18 billion in the period 22 to 28, while in case of collaboration among operators for the development of the network, which is able to accelerate the penetration of 5th generation wireless technologies by 1.5 times, GDP growth may reach to $6.27 billion or 5.51 billion in euros. Focusing on employment, 5G is expected to create 31,000 new jobs in our country by 2028, while in case of collaboration, the increase in employment may reach 46,000 new jobs in the same time horizon. The path to 5G solutions and services, both at the consumer and business levels, will not be easy for any company. From our primary research and the data collected, we strongly believe that the acceleration of the development and usage of 5G in Greece depends directly on the implementation of 8 basic but related actions. Acceleration of the spectrum auction process, encouraging investments, demand uplift, addressing technophobia, handling the security challenge, embrace collaboration among network providers, ecosystem enablement, encouraging innovation. I will make some remarks on 2 of them, given the time restriction I have for the presentation today, starting from the ecosystem enablement. In order to accelerate the exploitation of 5G and its potential to multiply the benefits for society and the economy, the coordination of many stakeholders is required in order to exchange know-how and experiences. For example, 5G may be proven a technological catalyst for companies that belong to the Industry X family. This transformation will require the constant collaboration and effective communication among multiple parties, including manufacturing of consumer goods, industrial manufacturing, chemical, pharmaceutical, natural resources companies, as well as telecom operators, strategic consulting firms, system integrators, software development companies, equipment manufacturers, cloud providers, academic researchers and universities, the central government, and maybe also the European Commission and associated funds, also as shown in the specific slide. In particular, the collaboration between business, universities, and research institutes and the state is considered to be of major importance. In that context, the Ministry of Digital Government recently announced the establishment of FESTOS, which will be funded by 20% of the proceeds from the spectrum auction in order to create 5G ecosystem in a number of sectors such as tourism, health, industrial production, and logistics. As said, a key milestone towards 5G wide adoption is the reinforcement of innovation. Encouraging innovation initiatives focus on not just 5G, but also other promising technologies such as artificial intelligence, the Internet of Things, and robotics that will be facilitated by their coexistence with 5G is a complex process in which the role of the state proves to be decisive. In this area, the state can though, through a series of relevant actions related to the regulatory framework, taxation, can enhance the formation of a climate in favor to the innovation. Certainly, the private sector needs to lead that race, of course. To sum up, Greece is still at the beginning of its journey to the promising era of 5G. On the other side, it has a unique opportunity to start its path to 5G dynamically and with determination, making the required leap towards full digitalization. After all, this was the trigger for us as Accenture Greece to proceed with the preparation of this holistic study in order to highlight through its result and to stimulate in the public debate the need for immediate and at the same time well-planned actions for the adoption of 5G in the country. The main findings of this study reveal that 5G has the potential to be strongly linked to a growth path for our country in the post-digital era. Consisting of a wealth of reasonable findings and immediately feasible proposal, this study can be a highly useful tool for business leaders, stakeholders at all levels, contributing significantly to the shaping, adoption, and implementation of the necessary roadmap of 5G in Greece. All the details of the study are publicly available for everyone interested too. Thank you for your attention today. I'm looking forward to hear additional thoughts and ideas about 5G during the day. Once again, many thanks for having me here today.
Thank you, Vangelis. Thank you very much for this nice presentation. I don't know if from the audience, are there any questions to Vangelis? Before they start, I have two questions regarding, the universities. Vangelis, you mentioned, I mean, it's pretty obvious that the impact of 5G to e-learning will be huge, and especially during this period that we experience. I mean, how big is the investment for a university in order to adopt all these 5G, how can I say, all these 5G capabilities and facilities? I mean, it's going to be a very big investment, or?
Konstantinos, as far as the networks will be ready by the telecom operators, and this is what we are hearing is the case for the country starting from next year, 2021. I think that relying on the network to use application as the example that you mentioned, it will require some investment, but the investment will be, I will say, of great value, and it cannot be considered as high according to my view, because we are discussing about application and software that has been heavily using even today, but it will be more reliable and more with lower latency given the new network. So we are going to see, I will say, scaling of those applications to facilitate the work from home or distant learning across the board. And we think that I think that this will be made without major investment by the.
Thank you. And the next question that I have for you, Vangelis, is like you mentioned something about Christos. I mean, this is a project that someone, in order to join it, should submit a proposal, or it's like an application form that you submit to the ministry and automatically you can join this consortium?
Konstantinos, the idea of Festos is honestly a very pioneering initiative that was made by the Greek government. It's unique across Europe. The idea is that to create an ecosystem which, as I mentioned in my speech, and it was revealed also by the study, is a key component for 5G to scale. So the idea of Festos is to attract all the necessary parties, and this is, like entities, this is a public and private, of course, sector, to ideate and join develop use cases that are related to 5G. To make this possible, they are also had the idea to use some of the cost of the spectrum auction that will be made by December in the country to be invested, to be used by this fund for innovation and for, as I said, use case creation and testing and industrialization. It is also, it is under discussion the exact setup. Of course, the ministry has more, in their plans have more details about how this will be evolved. But the high level idea, as far as we know, is that attracting all the players of the ecosystem, joint development of use cases, relevant needs, addressing relevant needs of businesses in Greece, academia as well. And funding will be made through the spectrum auction. 25% of this cost will be returned back to the 5G, let's say, ecosystem, but also attracting all the private sector that is willing and able to co-invest. So it's going to be, let's say, open to all the companies in the country and outside the country willing to be part of it. All the details will be announced and will be more clear, I think, in the next months or so. But this has been publicly announced, and there are discussions and in terms of details and how this will finalize.
Thank you very much. And can I ask you another question, the last one, because I would like to give some break to the participants. I mean, I noticed from the previous speaker, Hans, that they made the transition from Ericsson equipment to from Huawei equipment to Ericsson.
Yes.
I mean, probably Hans is with us, but I would like to know why. What was the reason? What were the reasons for this transition? Probably it's like technology. Probably Ericsson provides a higher technology, more advanced technology than the Huawei, or it's security reasons. Because if the companies, they are worried about the security, what about us as a citizens? How much we should worry about our privacy if this 5G communication arrive? I mean, not if, it's next to our door.
I guess the question goes to Hans, correct? Because
to Hans, to you.
I don't know the exact reason for this technology swap.
All right. Okay. So, any comment regarding this rivalry between United States and China regarding the 5G? Why all this dialogue and all this noise happens?
If I can say something, I think it's a multi-factor topic that is not related, to my view, only to technology. That's what I can say.
Okay. Okay. All right. Thank you, Vangelis, very much again for the presentation and your contribution. It's very important for us as a university. Thank you again. So I suggest that we can have a quarter of break and we can start 1:30 with the next speakers. The next speakers, they are coming from the OTE. And then we have a contribution from abroad again. So we will start with Dr. Agapiou from OTE, Deutsche Telekom Group, and he's going to speak to us again about, he's going to speak to us and introduce us to new applications of 5G communications. And then we will continue with Dr. Onopas, that he's going to link 5G with IoT. And then we will have a contribution from Qualcomm, from George Chirchis regarding 5G device evolution, and then we will make another break. So let's do a break for a quarter, and then we can continue with the 3 next lectures, and then another break will come. So have a break and come back in, let's say, now 10 minutes. Thank you very much.
Thank you, Konstantinos. Thank you.
Actually, for the speakers that they will remain in front of the computers, it will be nice to play a game or, you know, make something like a registration of your of the profile. So let me share my screen with you. And let me my computer. So So present. So if you go to Mendy.com and use the code 124530, probably we can, during the break, we can do this questionnaire and we can see lively and introduce each other through this kind of voting.
قديش 12
It's better,
40
excuse me, it's better to mute your microphone. So I think that if we can receive something like 80 to 90 responses, we are 146 now logged in, 147 until we start with the next speakers. So you can go to Mendy.com and use the code 124530. So the majority of the people are undergraduate students, postgraduate students from the market, very few academics. Probably the academics, they took the advantage of the break and they went for a short lunch. So let's move to the next question. Can you tell us if you're female, male? Marius Julius Keranakis, it's better to keep your question for the next speaker. I think that what they have mentioned is like Wi-Fi will stop to exist with 5G, or probably, I understood wrongly, but this is what did I get, that we are not going to depend on Wi-Fi. So let's move, all right, let's give some time more. Okay, let's move to the next one. The field of your studies or profession: electronic engineer, physics, economics and management, other. So I will keep this number of voting. I think like around 53, 56 people are with us right now during this short break. So thank you very much. So I'm moving to the next one. Please inform us the name of your institution or company. We have a participant from Vilnius Tech, our partner in the Athena European University. Welcome. Thank you. Let's move to the next question. So where does your institution company locate? I mean, the majority of them, I am expecting Greece, Lithuania, from what I have seen, Athens, Sweden, Algeria, Poland. Wow.
Thessaloniki.
Thessaloniki, yes, I can hear. Okay, we have the 52. This is the sample that we have right now. Okay, let's end. And let's move to why do you participate in this webinar? Is it problem to enter the code? Mm-hmm. Mm-hmm. And this is the last one. How do you learn about this webinar? I suspect that Pericles is among the organizers. Otherwise, I was expecting, some contribution from the IEEE network. So I'm considering that because Pericles from the IEEE is one of the organizers. Okay. Mm-hmm. Okay, thank you very much for this. So let's stop share. We have something on chat. Καλησπέρα, πληροφορικά απλά δεν μας ενδιαφέρει ιδιαίτερα. Mr. Nikos Boubouras, I agree with you, but yes, we can provide, if you wish, we can provide a certificate. Thank you. So thank you very much for this, also your contribution through this this voting. Let me, and it's time to come back to our schedule because we are a little bit tight, but we are on time. I would like to thank Dr. Agapiou, who is the next speaker from OTE. He's the head of research and development group over there, or he's involved very much in the research and development in OTE. OTE is our national carrier. So the floor, Dr. Agapiou will talk to us and will discuss with us, and he will present applications of 5G communications. It's something that excites us, and I think that also excites students. So the floor is yours, George.
I think you can see my screen, right?
Yes, George, we can see your screen. You have 20 minutes, and we should be very strict in this section. If you can make it shorter, even better.
Yeah. It's shorter.
Okay.
Don't worry.
I have George Sitsis.
Yeah, okay.
He's waiting. That's why.
Okay. Fine.
Thank you.
Okay, my name is George Agapiou. Thank you, Konstantinos, for inviting us. I'm coming from OTE Group. I'm not the director in research. I do research because I like it. So I'm one of the, let's say, managers in the core lab. Just to give you a short presentation and overview of what I'm going to present. First of all, I'm going to talk about what is the motivation really to have 5G. And you know, we are moving every 10 years pretty much. We have moved from 3G to 4G now, pretty much soon, I hope next year, we can see also 5G. So what is the motivation? Then we are going to go to talk about why we need 5G. What is the evolution in the mobile communications? What 5G will enable businesses to do? So why we need 5G and what they are going to bring to businesses. And then I will provide you some scenario applications, use cases, whatever you like to say. Usually in the projects, we call them use case scenarios. So I'm going to show you some applications in e-health, media applications, in disaster, which means in catastrophic situations, and also some applications in smart city and IoT. Some of the material you heard before, but for the students, I think it's good, you know, the more you heard, the more you absorb. So regarding the motivation, just to give you a little bit of a background of when 5G started, well, I think it's quite a few years ago, at least in research. Maybe 5 years ago, that's when we started the first projects or more. So the focus pretty much was on the spectrum, on radio access lately. We have the software-defined network technology. That's where the user plane is separated from the control plane. And that's one of the innovations, let's say, of 5G. So the data are closer to the user, and pretty much the control and all is done in a central location. And this is quite a bit of a difference with the 4G technology that we have now. And also in the radio access, we're going to have, I think the professors Kanatas and Karagiannidis talked about. So we're going to move from the big stations, radio stations that we have now, to much smaller base stations, which are going to be in very close, let's say, distances in order to accommodate this high bit rate that you heard, or this more latency. Also in 5G, we have the cloud infrastructure, and as I said, the network function virtualization. This virtualization is already, I think, implemented in most operational companies. We have also flexible management. That's what we're going to see in 5G, which is something I think very, very new. So we're going to implement, and we're going to supply dynamically resources according to the needs of the users. So the question is why we need to investigate how to implement 5G networks and how they can be employed in different media applications and business innovations. And of course, as you heard before, the idea is really to see how why we need low latency, why we need high bandwidth, and why we need flexible and dynamic infrastructures. So why we need 5G and what is the difference with 4G? So on the left side, what you can see is pretty much the main advantages that 5G is going to offer. And then on the right side, we see what 4G is offering right now. And pretty much you can understand the difference. So 5G uses massive MIMO, which is the case that you have an antenna or many antennas, but you have many receivers and transmitters at the same point, which means that you have many beams that spotlight a certain area, and these beams follow the user, so the user can have better quality of experience or quality of service. While in 4G, we have, let's say, pretty much a stable radio signal, and we can say that quite a bit of this signal is wasted. In 5G, we're going to use new radio with higher spectrum, 3.5 giga to 28 giga, which means not only the frequency, but also the bandwidth is going to be higher, 100 megahertz or maybe 1 giga. In some cases, if we go to higher frequencies, 80 gigahertz and so forth. So, you know, I think that the higher the bandwidth, the more bit rate or the higher the throughput is going to be to the end user. In 4G, we have frequencies up to 2.5 gigahertz, which means less transmitted data, but also the bandwidth. I think usually we have as operators 5 megahertz, 10 or 20, pretty much. Also 5G, one of the advantages is that is going to be a gateway for the Internet of Things, which is all of those sensors which are going to be connected to each other. And this is really a revolution for data-driven companies. And we can see that the difference that in 5G, we can have a connection of 1 million, let's say, devices or sensors in an area of 1 square kilometer. While in 4G, we have about, you can see here, 4,000 devices per square kilometer. Also, talking about the evolution, we can see that in 4G, pretty much the technology was used for consumers like us. We have a smartphone. Usually we use it just to download data, to see a video, not with so much quality of service. And in 5G, I think the enabler is to move to businesses. So we are going to see new businesses that come into the arena. The characteristics that you see here, I think you saw before. In terms of bit rate, you know, we can have the maximum, those are the maximum values that you can see here in this column, 1 gigabps, but the average is about 200 to 400 megabps in case that you have many users. And the latency, of course, as you heard before, is going to be much lower, or it's needed to be much lower than what we currently have. For example, now we have 20, 30, sometimes in 10 milliseconds, if you are very close to the base station. But in 5G, according to the recommendations and to the standards, probably also we're going to see latencies close to 1 millisecond, which is very challenging to the operators because they need to have many base stations. The user needs to be very close to the station. And also the controllers of the systems are going to be very close also to the end users. So 5G, as you can see here, as I write, is 10 times faster than 4G. Download can be quicker to smartphones and tablets, so you can download a video much faster, which is something I think useful. The gigabyte speeds on a 5G network is going to be useful for 8,000 virtual reality headset, and sometimes for those applications, we need bit rates of that start maybe from low 50 megabps, but they can go up to 800 megabps in case that the user is using those VR glasses that have 360 degrees observation. while in 4G, this is pretty much is not able to do it. And in 4G, we have pretty much high definition video. And we need to be sure that we understand that 5G may be a hype for consumers. And this is a very, usual question that you can hear from many people or also from the operators, why we need 5G. So what 5G will enable businesses and industry to do? So here's a little bit of discussion of what businesses or new businesses, let's say, we're going to see new stakeholders, new businesses that come to the market and how they are going to come. 5G, as we said, is going to be the catalyst or the main driver where humans are going to be connected to machines. And this is going to be to bring business and economic opportunities for new companies to come to the arena. We are going to have haptic applications, which means I have some use cases later. You are going to see where you have a tactile sensation, different instruments or machines, where you can have some operations place. So you can have, for example, remote operation of robotics or remote sensory surgeries by doctors, which can be achieved when a machine is, let's say, thousands of kilometers away. For critical applications, for example, in the car industry or in a disaster event, those cases, they require quite a bit of low latency because usually for the cars, you need to avoid an accident. So anything bad that is going to happen, we need to prevent it in milliseconds. The same in a disaster or in a catastrophe event. In an earthquake, something like this, you require very low latency so that the first responders or the rescuers who come to the event really to take care of the people who are injured and so forth, they can have very, very quick communication to each other by wearing some wearables on their hands and communicating to each other, or by having drones which bring a very high quality of the video to a central point. Also, 5G is expected to create truly connected and smart cities and autonomous vehicles. And this is, here we have also the protocol, the northbound IoT, which is, let's say, smart parking already is used also by OT Cosmote. And you are going to see also some use case later that is going to show some autonomous vehicles, robots, which are moved by using 5G technology. 5G also supports slicing. I think, I don't remember the name, but somebody, I think Hans, talked about, not Hans, the other guy from another company, but anyway, he talked about slicing. Slicing, it's how really to separate a network into many pieces, let's say into sub-networks, something that we do not have in 4G, which means that you can have a network which is secure. You can have a network which is dedicated, for example, for rescuers. You can have also a slice of the network which is dedicated for some teleconference and so forth. Here we go to the different, as I said, use cases scenarios. And those that what you are going to see from now on is pretty much the outputs or some cases that we have from research projects. Here is one case, we have an e-health scenario, and that was used in the SliceNet project. You can see here what is the challenges is to have very low, low latency because you need to provide very, very quickly, or the doctor needs to have a quick responses, a quick communication with people who are in the ambulance. We have also 5G critical slicing for the emergency data and services. And what 5G offers, sorry for What 5G offers is a universal coverage, reliable network, secure, ultra high bandwidth, and ultra low latency. And those were the KPIs, or let's say the requirements, which had to be achieved in order to show this use case to operate. Another application, which I think the undergraduate students, we have many of those, I think probably they like, it's media applications. We had another project, 5G Media, where we showed immersive media, immersive, which means that a player is really is embedded in the game, and you can see on the left side here you can have a player, on the right you have another player. They play to each other. So what happens here is a user, the player, is using those 360 degrees glasses and the augmented reality glasses, and also some high quality cameras in order to play the game. And also we have another scenario where we have the broadcast media, where very high bandwidth was required, about 20 gigabps to transfer, to broadcast a video from, let's say, from Germany to Greece. And the challenge is really, at least for the game, is to offer quality of service, quality of experience are the top priority. For that, we needed, of course, high bandwidth and low latency, although the latency pretty much, because we played the game in the internet from Thessaloniki to Athens, was pretty much, I guess, quite high, about 50 milliseconds, but the game was played quite well. Here we have another application that can be used and utilize 5G. It's a disaster situation. Here you can see the area in Megara, where we had a visit and a scenario pretty much 2 weeks ago, I think. Here, if you can see, there's a little drone that takes the picture of the first responders. Those people are the first responders. Those are volunteer rescuers who go to take care of the injuries or to help other public companies that go to the event. And on the right picture, you can see an area in Madrid. It's a very nice area where they have a simulated catastrophic event. They have some buildings which are destroyed. And that's the area where they train dogs and also first responders, how they can take care in such situations. Those people are wearing wearables in their hands. Drones are used also. So we can think about a large number of sensors, IoT case, Internet of Things case, which are needed to be taken care by a large number of base stations in case that we have many of those sensors. And also latency is important in this case, because the communication between the rescuers has to be very quick to each other in order to, let's say, to save a life for the injured people. And also the communication to the central point between the people who go here to rescue a person needs to be transferred very quickly to the central point to take some recommendation what to do and so forth. So that's the outcome of the project 5G Faster. And here we have the last case where we have smart city cases, Internet of Things, water environment control, fish farming, automated guided vehicle. So here you can see we have there's a case where we have 3 projects, 5G, Tours, and HART, where we have, or we are going to implement because the projects are still live. And here we have also in our group, we have Ericsson and Nokia, competitors, but in the 5G, we have both of them, but in the other 2 projects, we have one in Tours and one in HART. And we are going to implement 5G and 4G. Up to now, we are using 4G. And we are going to upgrade this technology to 5G in order to implement these use cases. Also, we have some smaller companies like Wings, which is here to offer the smart city applications. Of course, you can see the challenges. For example, if you have a water control, you can avoid the leakage and you can avoid the time that it takes to repair a leakage. Or in terms of measurements, you need to have a large number of sensors. The impact is that by using the northbound IoT, which is currently used in 4G, this is going to move also in 5G. And this is something, and this is an area where in these frequencies we do not have any interference. And of course, we can have as an impact, we can think about that we have money and time repair savings in this case. So pretty much this is all I had to say. Thank you very much.
Thank you. Thank you very much, George. Thank you for keeping the time. It's something that we should take into account of any presentation. Any questions? Okay, we have a question. Thank you, Orestes. What happens in the event of an earthquake if power grid goes out? Will 5G base stations stop functioning or are they battery backed?
Actually, in those areas, I have some pictures, but I did not put it in the presentation. We had the first responders always bring some power generators because, you know, the disaster event may happen in an area where there is no electricity. So always there is a, you know, battery backup, power backup in order to accommodate communication.
Mm-hmm. Thank you.
And also, if there is no mobile communication, because in the area we went in Megara, there was no communication at all. So we needed to install pretty much 5G technology in that area.
Mm-hmm. How fast did you install these facilities?
Yeah, well, it took us a while. It took us about an hour and a half because, you know, it was the first time that we did this, you know, and of course we didn't do it in a fast way, but in the case that there is a real event, probably I think people will be trained in order to do this very quickly.
Okay, and I would like to ask you the last question from my side. Is like I was attending before a year a conference regarding the earthquake, and I'm not involved in this, but I just went just from the curiosity. I participated just from the curiosity, and they mentioned how fast. I mean, they have detection systems like within the sea or far away from the areas, and how fast the earthquake they can detect the earthquake, but since it travels very fast, it takes, you know, few seconds in order to reach the urban area. So probably, you know, do you think that the 5G will help all these early warning systems to operate better? For sure they will operate faster, am I right?
Yes, that's for sure. As we showed, the idea is because we are going to have many more base stations, because what we have right now is the big base stations, which cover an area, let's say, of 3 kilometers. But with 5G, we're going to see many more small base stations, cheaper base stations, which are going to cover smaller areas within hundreds of meters, which are going to offer higher capacity, low latency. That's why we're going to have those benefits from 5G. Mm-hmm. So the response, of course, will be much faster.
Thank you, George, for this nice presentation. And we should move to the next speaker, who comes from OTE. It's Dr. Georgios Onopas. Dr. Onopas is a director.
Hello. Actually, I'm not a doctor.
Sorry.
I have an MSc degree.
So
but anyway.
Yes, thank you, George, to be with us. He's a director of the Fixed and Mobile Access Network Develops Department of OTE, and he's going to speak about within the next 20 minutes, and we should keep this time frame. about
Okay.
the connections of 5G with IoT. The floor is yours, George, and thank you very much.
Okay, actually, can you see my presentation?
No, you should share the screen first, and then we will be able to.
Okay.
See.
So it is on?
Yes, sir.
Okay. Okay, good afternoon from my side to all. First of all, I would like to thank you, Kostas, for the invitation. It is a great honor, actually, to be here today, even though by distance. And as well, it's a big pleasure that I have seen some good friends from the past as well. In my presentation, I try to give you a view of an operator about the 5G and IoT accelerating the digital transformation of our lives. So about Cosmote, I'm trying actually. It is okay. Actually, almost to increase. Let's say.
I think that if you place it on the full screen into your computer, it will be better.
Full screen. This is.
But don't worry. I mean, if you right click, okay. I mean, it's fine.
Okay, so actually, Cosmote is the biggest operator in Greece. It is it's a great honor from my side actually to lead the development of the access network of Cosmote more than 15 years. I have participated in the development of the 2G, 3G, 4G, and now the 5G. So one of our cornerstone strategy actually is to develop the RAN networks all over the country. Because actually the 60-70% of the inhabitants actually lives in Athens, Thessaloniki Valley, but they're not Athenians and Thessalonikians. They visit actually the home place twice per year, and it's very important for them to have coverage to them's homeland as well. And this is the criterion of them to be served with an operator actually in the big cities. So that's why actually Cosmote gives a lot of attention actually to provide coverage all over the country. In order to give you a flavor about the development of the networks, most probably Vangelis Kokkinos might remember that we have started the development of the 3G since late of 2003, and we finished the development late of 2017. So 15 years it took us actually to run the 3G all over the sites. On the other side, actually, the 4G we have started late of 2012, and we finished it actually 2018. So it took us less than half of the years to deploy the 4G all over the sites, compared, let's say, with the 3G development. And the main reason actually was the demand. So the deployment of the 4G was faster than the 3G because of the demand. So the 5G as well, for sure, it will be faster than the 4G. I have here actually some let's say, figures from the mobility report of Ericsson, which definitely are obsoleted because the real values actually are higher than the forecasted ones. So already actually the coverage that we provide in the Greece, it is more than 98%. The traffic actually, it is more than 90% that is served over the 4G. And for sure, I'm pretty sure actually that up to 2023, the traffic over 5G will be more than 15%. Might be double actually than the forecasting which has been done by Ericsson in 2017. Already actually they have updated, let's say, this forecasting. So one big, let's say, learn from the networks is that the LTE as a technology was a super fast adoption. because of the capabilities over the data that can provide to the subscribers. Now, more than 60% of our subscribers actually is LTE users, and the traffic that generates, as I mentioned before, it is more than 90%. So, okay, I think that this is the figures, the behavior actually of the data is hungry. As much as you give, let's say, to a data subscriber, has the intention to get it. It's not like the voice. Data are hungry, actually. So as much as capacity you give, the subscriber intends actually to grab it, especially if the prices are quite low. So you can see actually that the growth of the traffic is exponentially. And believe me, actually, that the read values are more than forecasted ones. So 5G, it is an evolution or revolution. 5G is expected to be more than a new generation technology, to be honest. 5G will be a key component enabler of the innovation, and it will be the key infrastructure for the digital age. So what this brings us to the 5G, I think that the previous speakers actually, they have mentioned thoroughly, bigger, higher throughputs, less latency that give us the ability for new services, bigger bandwidth, massive connectivity, and this is it is actually an answer about the previous question, that the 5G, there might be much better performance actually over crash, let's say, events like earthquake, because can support massively connections. So mainly through the earthquake, let's say, time, the most important is the signaling level. 5G actually has the ability to handle better actually the signaling. It will bring energy savings as well, more availability and coverage. But for us, as a guy actually that is running networks and deploying networks, I can say that the networks, you don't development in an evolutionary way, but a revolutionary way, because you have existing subscribers which must serve the needs. So the dynamic spectrum sharing feature, actually, it is a very good concept that most probably all the operators will adopt it in order to create blend of technologies covering all, let's say, the technologies, because it's very actually sexy that adaptively to allocate spectrum according to the needs. For sure, actually, it's not a feature. Through some pilots, trials that we have done, it's more a network than a feature. And actually, for the time being, there are some limitations that they are coming from the handsets that they cannot utilize all the abilities that the networks can provide to subscribers. So, in order to have the previous, let's say, abilities, we need spectrum. We need actually to reshuffling the existing spectrum, a new spectrum, by an efficient way. And I think that the DSS, as I mentioned before, is an ideal way in order to utilize the resources, your resources, with the best way. Of course, actually, the 5G will bring challenges. One of the challenges, it is the EMF issues. As have been mentioned before from the other speakers, the MIMO techniques beamforming, definitely they will be used for the 5G, but brings complex EMF compliance. And definitely the way that the limits will be calculated should be revisited, actually reevaluated. Higher frequencies above the 10 gig should be considered as well. How we can actually measure the EMF over the 10 gig. Another big issue actually might be the licensing process. It is more than obvious that after 2025, We need actually to densify our networks. All the operators, initially, they will start to deploy 5G for the existing sites, but later on, it will be a necessity, the densification of them. And this will be done through the deployment of another layer of the small cells. But in order to do that, definitely you need more, a lighter licensing process to give you the ability to utilize existing infrastructure in order to invest on the network and not on the infrastructure. So there are cases, for instance, actually in Switzerland, that for Volt sites, but the licensing process in Switzerland gives you this ability. This is, I think, a concept that has been developed for cooperation of Ericsson with the Swisscom. Here in Greece, actually, we have done some pilots with open mayors, like in Drama, which gave us the ability to build up some small cells, like lighting poles. This is not only photo; they are real, let's say, implementations, like flower pots, or to reuse passive cabinets with smart lighting and meteo data that is, let's say, provided to all the users. So you can see actually the implementation here of these sites. So, as I mentioned before, we see these two big challenges. One is the EMF, and the other one is the licensing process. So, about the IoT market outlook actually is again, the market is increasing exponentially, even though for the time being. Actually, the IoT will reshape all industries, value chains, entire business configuration, and human behaviors. Actually, I can say that it is the first time in my career that I can see that the network has the capacity actually, or has the way in order to serve the needs, but applications are not there. And believe me, actually, that I can see a huge, let's say, in the upcoming years, actually, a huge investments on the applications. And I can say that the current government actually gave the opportunity to the Festos fund to support, let's say, new ideas would be very helpful. Because it's just to have the inspiration. And inspiration, actually, inspiration, all of us will have, let's say, the right to have inspirations. And this actually I can suggest to the students, think about a new application, whatever it will be. The network will serve it. If it will come actually to serve a need, it will be a successful one. So smartness will be all over, will be in the smart cities, in the environment, the industry, in the business, in the houses, in some special industries like the ships, in agriculture, wearables as well, all over. So in order to have some takeaways and conclusions. The 5G actually will start as a mobile evolution, but will become a revolution and enabler. That we will enable new functionality for the people, business, industries, all over. Will give actually the ability to deploy new applications, machine to machines. And this is actually, that is very important, it's very interesting that for the time being, can be served over the 4G. Over the mobile, over the standards of the narrowband IoT. These standards actually have been developed over the 4G, and this came from the industry, because the industry already has needs, and the networks can provide the ability actually to serve them. So that this is actually that we will see is to prepare the gigabit society from the time being by using the LTE advance. gigabits. And not only the gigabit society, but the whole IoT market. So the new era is already here.
Thank you. Thank you, George. I think that the students, they should keep the message that you send it to them, that they should find something new. I mean, don't try to do the same and the same, but actually this is the mission of our young students and young researchers, to introduce something new, something out of the box that we cannot think, and it will have an impact. Are there any questions from the audience? I think that I have received a comment from John S. So John S. mentioned the following: I do not know what is going to be in the future, but at the moment, and especially in the islands, most of the fixed telephony stations are not battery backed up. And for the cellular base stations, I do not think that power redundancy is the operator's first priority. Since you are coming from an operator point of view, George, can you comment on this?
Actually, all the sites, they have battery backup, but of course the battery backup, it doesn't last more than a couple of hours actually.
Mm-hmm.
If you have a severe, let's say, accident of power cutoff, for sure, actually, it's very difficult the sites to survive. But we're talking about cellular networks. So the coverage actually is not provided only by one side. For sure, over the islands, it's more difficult actually to have overlapping. But in Cosmote, actually, we tried a lot to provide coverage not only from the islands, but from the neighbor island as well.
Mm-hmm.
So most probably this technique actually can increase the availability of the network through this very, let's say, serious cutoff of the powers.
Mm-hmm. Thank you. And there is another question from Evangelos Soter. Thank you, Evangelos, and thank you also, John, for the first question. When are prices expected to lower for 5G?
The prices, you mean?
Yes.
Okay, I think that up to now, Cosmote follows the following, let's say, approach. We didn't actually distinguish, let's say, the provision of the data, if this is happened over the 3G or the 4G, or in the future over the 5G. Mm-hmm. So the price, there will be, let's say, the same if, let's say, the needs will be served over the 5G layer. For sure, this will not be for free, but the trend will be, let's say, the cost per megabit to be lower in the future.
Mm-hmm.
That's for sure.
Thank you. Thank you. And I think that this is the normal situation with all the technologies. When we are moving from one technology to the other one, probably the prices are higher, but then we have a stabilization of the prices. Am I right?
Actually, as I mentioned, that the approach of Cosmote was not this one, actually. We didn't distinguish the price per network. So I can say that through the years, the trend of the tariff policy of Cosmote was to be lower, mm-hmm. even though when we have deployed a new layer.
Mm-hmm. And the last question before we move to the next speaker is: when should we expect? When should we expect more or less to have achieved a great 5G coverage in Greece and specifically in Crete?
In Crete, okay. As I mentioned before, okay, actually, if we will see, let's say, the trend globally, you can actually separate it in three trends. One, it is in Asia, actually in China and in Korea, in North Korea, where the operators they developed from the beginning a new layer of 3.5 for 5G. This is one trend. Another trend actually is in US, in North America, where they deploy the 5G layer over millimeter wave. especially to provide the fixed wireless access abilities. I think the Americans mainly they do that because they have problem with the usage of the 3.x spectrum band. This is the main reason, and because they have a lack of fibers. I can say that only the 20% of the inhabitants in the US it is on fibers.
Mm-hmm.
So you can imagine the need for them to have fixed wireless access products. In Europe, because the operators they have invested heavily on 4G, most probably they will follow a different way. They will use dynamic spectrum sharing. That means actually they will deploy the 5G networks over the mid bands, over the 1.8 and 2.1, the existing frequencies bands, like in Switzerland. If you consider this, so the coverage of the 5G will be increased dramatically in the upcoming 2-3 years. We will exceed the 50% of the population coverage,
included
by using the dynamic spectrum sharing techniques.
Included grid.
Including the grid, yes.
Okay, thank you. And last one, but I mean, if we can provide it very fast, I would like to, it comes from a student, I would like to ask if the plan of 500 kilobytes in narrowband IoT network is enough for a sensor sending data in fixed time intervals.
Okay, the narrowband IoT protocol actually it is for metering applications. That's for sure. But they are coming the CAT-10 protocol that can allocate quite a lot of spectrum, not only to 200 kilohertz, but I think up to 1.2 megahertz, in order, let's say, to serve the needs of more data-hungry applications. So in order to answer to this question, I think that the most appropriate protocol will be the CAT-10 for this kind of applications.
Thank you very much.
It is actually available. Mm-hmm. We have not actually deployed. We have deployed narrowband IoT. We have, I think, more than 24% of population coverage. But it's something actually that is available from the networks, and most probably we will deploy it.
Mm-hmm. Thank you very much, George, and thanks also Vangelis Kokkinos for bringing you with us here. And
I also want to thank George.
No time. Thank you, both of you, for the nice presentation and Mr. Onopa's introduction to our webinar. We should jump immediately to our next speaker.
Thank you, George.
George, please stop sharing. Our next speaker, it's a great honor to have with us Mr. George Tsirtsis. He's going to speak about 5G devices, something different than the previous lectures and presentations. And actually, he's a director of technology in Qualcomm. I have learned from my colleague Vangelos Kokkinos that Qualcomm is like a very big player in the industry. I'm coming from laser, so I know only coherent and the spectra physics. So thank you, George, to be with us, and the floor is yours. And as you can see in Greece, we are British in our schedule. The floor is yours, George.
Thank you. Thanks a lot, Kostas. Let me then continue the trend of speakers named George here. So I think I'm the third one on the road. So this is great. So my name is George Tsirtsis. I'm working for Qualcomm Europe, based in London, and I'm overseeing the 5G activities of Qualcomm in the European region. So I'm going to talk about 5G devices. Let me start. Qualcomm, first of all, has been involved and actually forefronting every cellular generation for the last 20, 30 years. And we are very much in front of the 5G generation from its inception, standardization, prototyping, and product development and deployment. So this is great now to see 5G being deployed all around the world. Indeed, 5G is now has been launched in all continents, both sub-6 and millimeter wave variants. And as you see, there is a large concentration of dots there, 5G launches in Europe. So this is in fact more detailed. These are all the operators and countries that have launched 5G so far in Europe. This is mainly gated by the availability of spectrum, the auctions. And as you see, we have there coming soon France, Greece, and Czech Republic. And I have been watching with a lot of interest the auction process in France and Greece, and have been hoping that we beat the French here, but they are currently a little bit ahead of us. So let's see how that goes. So all of these deployments worldwide and in Europe utilize, of course, devices that are largely powered by Qualcomm technology, where we provide application processors, but importantly for this, in this context, the Snapdragon modems and RF systems. What you see here is X60 is the latest offering that we have. Is the most comprehensive solution to date, providing 5G modem and RF subsystem all the way from the baseband to the antenna capabilities, including, of course, all the previous Gs and all the variants of the 5G technology that is necessary today, including non-standalone, standalone mode, DSS that was mentioned a few times, with, of course, NR, 5G NR on both TDD and FTD bands in sub-6 and millimeter wave bands. So very comprehensive solution. And also on the millimeter wave side, we provide fully integrated antenna modules that are specifically designed for the smartphone form factor, and then, of course, many other types of devices. And this kind of product, of course, it's the previous generation of it, actually, because this is X60 is going to appear in devices that come to the market next year. But this year already with the X55, which is its predecessor, we have 5G across pretty much the entire Android and now iOS ecosystem. You saw Apple a couple of days ago announced their first 5G phones that also carry Qualcomm technology. In fact, our premium tier Qualcomm Snapdragon 865 application processor and 5G mobile platform is in 165 plus designs so far. And I'm giving you this number because it's really just, it's well beyond smartphones, and I'm going to get back on that. So we power many different types of devices, and the ecosystem around 5G is already immense. Here you can see a subset of smartphone devices that utilize this Snapdragon 865 with 5G. All of these devices are available today in the European market. Of course, many more are in design. And of course, there are all the standard smartphone form factor devices, plus some interesting new designs that you see with folding screens or dual screens. These are all very interesting new developments in smartphone. And this is our premium tier, right? So these are the best devices, also kind of most expensive devices in the market. But in addition to that, we have what we call Snapdragon 7 series. This is powering devices that are still very high quality, but at a better price point. And this is something that we're working very hard to actually to enable lower price tier devices with 5G. So we have already announced the Snapdragon 6 series, and the devices will be coming soon. And in fact, very recently, we announced the first 4 series chipset with 5G. And this really brings device 5G down to devices that cost like in the region of $200 or less. You can say 200 euros or less. And this is incredible. Just 2 years after launch to have to be hitting these price points for devices that will be extremely powerful, even at this tier. So this is kind of, we are quite proud of that achievement. So I mentioned already that 5G is going well beyond just smartphones. So here I put together some examples of devices that are not only smartphones, but different types. And in this case, actually, I collected devices that support millimeter wave, in addition to sub-6. So these are all, again, available commercially today. And of course, there are many, many more in the making. In addition to smartphones, then you see laptops, which I'm going to get back on, hotspots and CPEs. CPEs are for wireless, fixed wireless access for broadband at home, and also modules. Modules are very important because they allow us to introduce 5G in machines, in laptops, actually, as well as in automated vehicles, in robots, in cranes, whatever you can imagine. So again, the ecosystem around 5G is developing incredibly fast, and we are definitely into kind of beyond the smartphone connectivity at this point. Laptops is a very interesting and important device for 5G, because one of the aspirations of the 5G ecosystem is to serve not only the consumer, but also the enterprise and industrial user and companies. And the laptop is a kind of the workhorse of a lot of that kind of vertical. And now we can do many things, not only introduce 5G on any kind of laptop with one of the 5G modules that many laptops can take internally. But importantly, the last couple of years, we have been working very closely with Microsoft, and we have developed what is known as Windows on Snapdragon systems. So basically, these are laptops that use the mobile processors, Qualcomm Snapdragon processors that are optimized, of course, for laptops. But then you run, instead of running Android on them, you run full Windows operating system. And there are, I'm actually right now using a Microsoft Surface Pro X that is using a Snapdragon processor inside. But this is the first 5G capable such laptop. So this is a Lenovo laptop, Windows Snapdragon with 5G out of the box. So these are very powerful laptops. The battery lasts forever because it's a mobile processor inside, and they are always connected. They turn on very quickly. Again, getting a lot of benefits from how smartphones work, but they are, again, run full Windows capability. So it's very, very exciting kind of device for 5G in the enterprise and industry. Another area that is generating a lot of different device types and is very close to my heart, and I kind of really enjoy this kind of area, is augmented and virtual reality or mixed reality. And we are now at the really very happy intersection of 5G getting very rapidly deployed across the world. And at the same time, this technology, the mixed reality technology, beginning to mature quite well. So at the moment, the cutting edge and most kind of consumer-oriented device that is out there is a VR headset from Facebook, the Oculus Quest. Actually, Quest 2 was just announced, and kind of see this early this week. This utilizes, again, a mobile processor from Qualcomm optimized for XR use cases. It's called XR2, but it is what we call an all-in-one device that is at the moment Wi-Fi connected, not cellular device. And the reason for that is that it's not a device that you can wear all day. It's a kind of has a it's a big headset that relatively big that you have in front of your eyes. And it's really for indoor use for smaller periods of time. The vision, however, of the industry is what you see on the right, with the glasses that look like regular glasses or sunglasses, and will be, of course, 5G connected and will be able to augment your environment as you wear them all day. But this is a few years out because there are a lot of challenges there, and this is kind of an area that is incredibly active right now across the world in terms of research and development. But in the meantime, what we can do is utilize the smartphone that is incredibly capable nowadays to offload some of the functionality from the headset itself. So you will see a number of solutions that have, there are glasses that beginning to look like this glass on the right, by removing the battery, connectivity, a lot of the processing out of the headset and utilizing what is already there in the smartphones. This is kind of the device that you see on the lower part of the slide. And this is not kind of science fiction. This exists today. I'll show you some of them. These are all in production. Maybe the Nreal, the red ones, there are more well known, but there are many of these that are in production, and you can see that they're beginning to look like something that you can wear for longer periods of time, to do either for work or entertainment purposes. And they all utilize at the moment with a cable, but even that will become a wireless connection, utilize the processing, battery, and connectivity that comes from your smartphone. So this is very exciting and big part of a big use case for 5G, because if you take that one step further, what is beginning to happen then is that we are, for the first time, moving from what has been a two-dimensional user interface for any interaction that we have been having from the written word to the screens, TV, laptops, smartphones, and tablets these days. These have all been two-dimensional, and we are moving into a three-dimensional user interface. And this will mean that we always interact with the cloud, with the internet in our everyday life, and this absolutely requires 5G to get to this vision. So this is, again, for me, it's one of the most exciting aspects of 5G and VR XR. Now, I kind of went all the way to the future here, but let me circle back and also add a kind of a perspective on what benefits you will see with 5G immediately as soon as you get your first 5G phone and a 5G subscription from one of the operators. You will notice immediate benefits, and let me start with these ones. Of course, as other speakers mentioned, the immediate benefits come from throughput and better throughput and lower latency. And this translates to things like this. So for example, any kind of content that you need to download for offline use, like anything from a new application that you want to install, or a TV episode, or a full movie that you want to be able to watch offline, these things will be happening literally seconds. You will see an incredible difference in terms of how quickly things happen like this. And another one that is similar but kind of a little bit less obvious, if you like, is the quality of streaming video. Any streaming video that you see today, either from YouTube or any kind of other streaming service, it's very rare on a 4G network to get it in the full bit rate that the video stream has been encoded at. Usually you get some lower rate because of the what the network can do, and it's only like 4 or 5% of the cases where you get full quality. Well, with 5G, that will be almost always 100%. So again, the video streaming quality you will experience will be much improved immediately. Another aspect that is going to be changing very fast is the relationship between the smartphone and the cloud. The smartphone, of course, was conceived as a device that where you download an app and then you run it locally. Then with 4G, gradually applications started utilizing the cloud, but it's still in a kind of limited way. With 5G, the smartphone and the cloud become one, essentially interchangeable. You can run anything either locally or remotely with different trade-offs. And we will see very quick evolution of apps to take advantage of this. It will be transformative very quickly. And I cannot avoid talking about gaming as another thing that will transform completely. It was mentioned also earlier, but gaming really is getting transformed already because the capabilities of Snapdragon processors with GPU, AI, they are enhancing that experience locally tremendously. So gaming on smartphones these days is already incredibly improved. But with 5G, what will happen is that you will not be constrained on games that you have on your smartphone. You will be able to get incredibly good quality gaming experience with games that are basically running from the cloud. And that again, it's going to be very beneficial very quickly. So happy gaming to everybody that is interested in this. And so this is what I had. Let me close by making a note on the power and scale of the mobile and cellular ecosystems. This is, don't know if people realize this, but the mobile ecosystem is one of the biggest things that humanity has created. You see the 5G projections here, which are not the total number of mobiles, but how 5G will progress. We're talking about 1 billion devices by 2023. We're talking about close to 3 billion devices by 2035. This is a massive ecosystem, and that's where its transformative power comes from. So I believe we are going to see great things in the next few years with 5G. I'm really excited that Greece is at the verge of launching 5G, and I'm really looking forward to what everybody will do with that, especially the students that are watching this and will be, I'm sure, inventing well beyond what we have imagined so far in the next few decades. So thank you very much again.
Thank you very much, George, for the presentation. I don't know if there are any questions from the audience. I can see some comments from Evangelos Ote. 5G smartphones for $200, 5G to the people. Thank you.
You're welcome.
There is another question from Marius Keranakis. This is a question: what is the average SAR index in 5G smartphones, and have they a big difference compared to 4G?
SAR index, what are you referring to?
I have no idea. I'm coming from a different area. So, Marios Keranakis, can you please elaborate? What do you mean SAR index?
Yeah, there are a couple of different acronyms with SAR. So yeah. If you clarify.
In the middle time, can I ask you something, George? From the chip makers side. So we know that because of the saturation of Maulu's law, I mean, we cannot make any more, you know, faster processors since we cannot integrate more transistor within a chip. And we are looking for new materials, like we move to graphene or to 2D materials that we try to increase and enhance and introduce higher mobilities in order to compensate with higher, faster processes. So what is your opinion on this? What is the impact of faster chips, like from the materials point of view for the 5G operations?
Yeah, so I wouldn't completely dismiss Moore's law yet. We are going still in, we are producing still smaller nodes in processing. So you will see that now we are into, you know, we are approaching, we have 7 nanometers, we'll go to 5 nanometers. It is and this is a process that allows us to keep packing more transistors into a smaller space. And then there are a lot of other optimizations that are still in front of us in terms of managing core structure, making specialized processors for, you know, already we have all these, you know, Snapdragon processor now has multi-core for CPU, has GPU, AI cores, ISP cores for signal processing. There are a lot of optimizations that are still ahead of us. And there is, of course, research on going, you know, beyond that and, you know, including much more advanced things like quantum computing, etc. So
quantum computing is something that we should not, I mean, they cannot operate, you know, under room temperature. I mean, there are a lot of challenges.
Exactly. So there are many research topics in that direction. So I think there is still a significant way with existing technology while other things are catching up, including materials. But in the meantime, I saw regarding absorption rate. So SAR is frequency related, not 5G, 4G related. So it is regulated from European level, and I'm sure Greek regulators also have their own rules, and this is all kind of business as usual. So nothing new there as such.
Thank you. Thank you, George, for the nice presentation. I hope that you have not missed the next meeting that you have. Because
no. You know, thank you. We have been incredibly on time. So
okay. So it's now we will move to the next presenter, which is among the organizers, is Periklis Hadjimissios. I have never met him, you know, face to face, but I'm feeling that he's a good friend, and he has supported the whole organization a lot. Actually, because of Periklis has organized a similar event during the first lockdown. I had the idea that probably with, you know, my colleagues here in the Department of Electronic Engineering, it will be useful to do something similar, but for the students. Periklis is also the head of the IEEE network in Greece. So Periklis, the floor is yours, and I'm pretty sure that you are going to present a very fascinating applications regarding this the impact of 5G communications to autonomous vehicles. So the floor is yours, Periklis.
Thank you very much for the invitation and the proposal to co-organize the event. Wearing my hat as the chair of Communication Society within IEEE, the Greece chapter. Can you see my slides as well? Okay. Okay, let me try to, okay. So I'm a professor in the International Hellenic University, which is a new university. Actually, it was old and it's new again since we became, if not mistaken, the fourth largest university in Greece. I'm a professor in the Department of Science and Technology, and until recently I was wearing the hat of the coordinator for Erasmus activities for 10 years. So I really understand what you are talking about when you actually organize an event related with Erasmus. So the title of my talk is going to be 5G communications for connected and autonomous vehicles. I will give an overview of what are the connected and autonomous vehicles, and I will talk after that about 5G and how 5G can potentially help us to realize this. And I will also refer to two projects that we have that are related with the topic. Now, if I'm not mistaken, we have not talked a lot in this seminar about
we lost the speaker. I think that this is an internet failure from speaker side. I don't know, probably it's better to jump to the next one to give some time for the speaker to come back. So I think that Mateo is with us from Barcelona. Am I right? Barcelona Digital. I think that he's with us. Is Mateo with us? I have seen him. So let's.
Hello.
Yeah, Tomeo, it's here.
Hello.
Let's jump to you until we give some time to the speaker to come back, because I think that he had an internet failure.
Okay, perfect. So let me share the screen with you.
Yeah, and thank you very much, Ricardo Tavio, for introducing for the introduction and bringing you here with us. Thank you, Tomeo. Tomeo is going to present something very nice, comes from the society. It's like a local initiative in Barcelona about the 5G, and you can see how a city reacts and reflects this kind of technology. So the floor is yours, Tomeo.
Hello, I'm going to share my screen. Can you see my screen now?
Yeah.
Yeah, so hello and good afternoon. My name is Tomeo and I work at 5G program at Mobile World Capital Foundation. And first of all, I would like to say thank you to the organization for inviting us to share our experiences this session. And as you mentioned, today I'm going to explain our activity regarding the 5G, which is mainly the executions of 5G pilots and 5G technologies. And today I'm going to explain you the pilots in the health sector. So first of all, let me introduce what is our organization and what are we doing. So Mobile World Capital Barcelona is a public foundation that was founded 8 years ago with the aim to improve the people's lives through mobile technologies. We run different activities and different programs, and I currently work on the 5G area in the 5G Barcelona Alliance, managing the 5G Barcelona Alliance. And the 5G Barcelona Alliance is a public-private initiative with the aim to become Barcelona the leading 5G hub in Southern Europe. We offer Barcelona as an open laboratory for the testing and validation of 5G technologies and 5G tests and 5G use cases in a real environment. And this real environment is our city, the city of Barcelona. And what we do to achieve our goal to be like the leading 5G hub in the Southern Europe, we mainly work with all the 5G ecosystem in different kinds of activities. For instance, we run like training to develop new competencies. We promote dissemination actions, roadshows and conferences to share our knowledge. We also conduct workshops with the industry in order to identify future use cases with real end users and potential end users. And we promote the creation of laboratories to accelerate the technology transfer related to 5G. And our main area of activity is the execution of 5G use cases with all the ecosystem in order to validate new services and verticals in all the industry verticals. So far, we count with a pipeline of around 100 use cases. So we are leading more or less the 5G use cases per number in Europe. So Today, I'm going to explain you several of those 5G use cases that are related to the health sector. Although these use cases there are proof of concepts and validations of the performance of the 5G technology, these pilots serve to seduce the health ecosystems as they became the early adopters of the 5G technology, and they start thinking in the new possibilities of the technology. They start thinking on perhaps new business models related to these services, and ensure that these pilots will set a path for the future services in the health sector. So let me start speaking of one of our early pilots, which is the 5G remote surgeon. This pilot was one of the first of use cases, and it responds to the fact that the surgery has advanced more in the last 15 years than in the past 150. Thus, this means that the surgical knowledge is compressed in a small group of surgeons of a very old age, and thus nearly 97% of the surgeons around the world are not able to travel to assist a congress or doesn't have access to a continuing education. As a result, each year around the world, more than 143 surgeries cannot be performed due to a lack of a specific knowledge. I'm going to share the video with you because we are not running out of time. So I prefer to explain the pilot as you are seeing the video of the project, okay? So this pilot started with the dream of one of the most prestigious surgeons at the international level, who is Dr. Antonio De Lacy, who dreamed of a solution to provide guidance to a surgeon from a remote place. So to this aim, Dr. De Lacy found ICE Channel. ICE Channel is a startup that has developed a solution to perform telestration service. And just to provide you some context, Dr. De Lacy performs the operations using a laparoscopic surgery, as you can see in this video. This laparoscopic surgery is a technique in which a short and narrow tubes are inserted into the patient's abdomen through small incisions. So through these small incisions, we can insert a camera into the patient's body, and we can use these videos and we can stream this video from the laparoscopic camera to a remote location where a surgeon can make a notation or take notes on the top of the video, and the video can return to the operating room. So surgeons can follow these instructions, and these instructions can be used as advice. So from here, everything sounds good because we can use this video streaming to perform an operation, but the reality was very different, okay? There was a delay of nearly 4 seconds between the two different sources of videos. So the company couldn't perform this operation in real time, okay? So as you can see in the video, as from now, that company solved this problem by freezing the video. So they sent an image with the annotations of the surgeon to the other groups of the surgeons, but it was not comfortable for the surgeons, so they weren't able to perform a surgery in real time. So at this moment, and this is a part of the work that we are doing in accelerating these ecosystems, ICE Channel, so this startup had no idea of what was 5G. So the company came to us and they explained that it has like a need. So they need they have a solution, but this solution cannot work in real time. So we saw this use case, and we saw this as an opportunity, and we went to Vodafone and to Huawei, and we explained this potential use case. So we start running a pilot. And what was this pilot about? So this pilot took place in 2 different landmarks in the city of Barcelona, which are separated with a distance of 6 kilometers. So on one hand, we had the Optimus operating room. The Optimus operating room is one of the most advanced operating rooms in the world, and it represents an investment of around 60 million euros. And on the other hand, we were at the Mobile World Congress Auditorium, and the Mobile World Congress is the largest technology event in the world. So in the test, one expert surgeon was located on the auditorium at the Mobile World Congress, and a group of surgeons were performing and operating on the operating room at the nucleus. So let me explain you a video of what happens during the pilot, okay? And you will understand much better. Here you can see the notes of the Antonio Lafi on the video from the laparoscopic camera. So as you can see here, this pilot show how 5G can allow an expert surgeon to send his knowledge to a remote hospital and guiding a group of less experienced surgeons and answering their questions. So 5G will allow the most advanced surgical techniques to be brought anywhere in the world, okay? And this surgical technique, from now on, they can be accessible to a great number of people, and we can bring these techniques or this knowledge to areas affected by disasters or in the developing countries, and it will transform the health sector in remote areas or in areas with fewer resources. And continuing with the project that we performed in the health sector, another project we run in the health sector was the 5G Fire Responders pilot, which was executed this year during February. And this is a collaboration of Orange, Ericsson, Cisco, Hospital Pare Taulí, which is a hospital in Barcelona, and Mobile World Capital. The aim of this pilot is to improve the attention in medical emergencies during the first moments, that these first moments are key to save the life and prevent serious injuries. As you will see in the video, this pilot consists of a situation where a child simulates suffering an epileptic seizure on the street. And as it happens in the real life, the first person who attends the patient is a policeman. And this policeman will initiate the care procedure by connecting with the pediatric emergencies doctor at Hospital Pare Taulí through a device which was equipped with 5G connected camera, as you can see in the video, and can be used to share images in real time. So with this technology, with 5G, the policeman was able to receive instructions from the doctor, who give instructions on how to provide primary care and stabilize the patient. So the use of this solution with 5G allow the transmission of high quality images and processed data in milliseconds. And it combines the collaboration of software, hardware, and 5G networks to optimize the first care. And it has a great impact on the health sector and into emergencies and in security, since it will allow like a fast and effective response in care of people in critical conditions. And to continue with the pilot and continuing of what are we doing currently, during this year, we launched a challenge in collaboration with the Barcelona City Council to search solutions which, based on 5G, can improve the quality of life of the elderly. And this challenge was very special for us because it attends to a social problem in Barcelona, since in our city there are more than 90,000 people over 65 years who live alone. So two solutions won this challenge, and we are currently piloting these situations with solutions, regardless of the current situation of the coronavirus, because it is very complex, because we are working with elderly people and with the lockdown circumstances. But we are piloting this solution with real end users in the city of Barcelona. And the objective of these pilots is to scale up these technologies in real healthcare services for the next year. And we are working with the Barcelona City Hall for this purpose. So the first of the winner was a pilot that we call 5G emotional robot. And in this pilot, we use a robot which is called Misty. Misty is a small and personal robot which is able to interact with the end users and provide support to their daily tasks. So it can connect with an external agent, or they can send information to help to analyze the cognitive condition of the patient based on the interactions and the languages. Let me play you a video when you will see the robot and the main purposes of the project. And this project is currently being executed, and we are testing the impact of the robot in the daily life of a group of 12 elderlies who are living alone, and they have like a minimum capacity to use technical devices. As I previously mentioned, the Barcelona City Council is a study to scale up this project and evolve this project into social services in the next year, in order to face our problem that we have like a lack of caregivers and the growing age of the population. As you can see here, you can see the robot and how the robot can interact with the users. The robot interact with the users, asking questions and facilitating their daily tasks. Then for ending, another of the pilots that we presented in this challenge was a pilot from Cisco, and this is a pilot is called Deleting Loneliness. And Deleting Loneliness offer a communication suite, so a platform that allow users to participate in immersive experiences and activities, improving their communication capabilities and improving their feeling of loneliness. And thanks to these platforms and examples of what activities can perform the users in these platforms, for instance, they can participate in discussions on different topics. They can be a part of a community because they can participate in collective activities such as a reading club or a do-it-yourself workshops, cooking lessons, or sport lessons, or with the immersive experience system. They can visit museums, they can go to exhibitions, or they can go to fairs. So the novelty of this pilot lies in the usability of the platform, and then the simplicity of this platform for the other person who are not used to technology, and the integration of 5G allowed like a high quality video conferences and a minimal delay, which facilitates like the real time in these conversations, and also the participation of multiple users in the video conferences. So thank you. That's all. So that's all for today. And I hope that you find this project very interesting and you have learned a little bit from our work. And to sum up, I would like to highlight that beyond the expectations or the hype created by these mediatic projects, okay, the most important part is that 5G is a technology that is aimed to all the industry verticals, and it provides a group of capacities that can be used to build the future services that weren't possible before. So thank you very much for your attention. And now it's time for you have any question.
Thank you very much, Tomeu. I think that this is a very good example for all the cities all over Europe. I mean, how Barcelona is reacting towards this technology. I don't know if we have any questions from the audience. Please write them on the chat, or otherwise.
I have a question.
Oh, yes.
Okay.
Thank you.
A very nice presentation. I know that Barcelona is a leader in smart cities, so congratulations for your work. So what is the funding of 5G Barcelona? What is the funding scheme?
The funding scheme, so we have a part for the Barcelona City Hall and another part for the government of Catalonia, which is Generalitat de Catalunya. But one of the most remarkable things is that all these pilots are conducted by private funding. This means we don't fund these projects. So each of the members, each of the partners who are participating in these projects, they have to provide in-kind fundings.
Wonderful.
Okay.
Thank you.
You're welcome.
I would like to ask something. So, Tomeu, I mean, I was very impressed by all these applications, by the capabilities and the options offer, especially to medicine. Let me mute someone because they don't like to do it automatically. I was wondering, and also I was impressed by the interface between humans and robots. But I think like how Barcelona as a city and as a society, let me mute another one, helps the people to accept this new technology. Because let's imagine myself, you know, I know my father was a surgeon, all right, and he brought laparoscopic in Athens, in Evangelismos. So it was the moment that he brought this from America and they operated with fibers, some people, they still prefer to have big scars instead to use fibers in order to make the operation.
Yeah.
Imagine myself. I mean, I will hesitate a lot to go to a hospital, and I should know that the doctor probably is in Florida and he operates me through Florida. And the other one is like how the old people, they will learn how Barcelona helps the old people to learn to live with a robot, because robot is an interface, humans is another interface. I mean, what is the input of the social workers in order to bring these two interfaces to communicate and learn how to live together?
Yeah, there are proof of concepts in the particular case of the robot. We are not only working with the company of the robot and with the mobile network operator. There are a lot of people working in this project. The Barcelona City Hall is involved in the project, and also there are social services in the project. There is the Department of Social Services of the Barcelona City Council, and we are trying to adjust the acceptance of the user with the robot. And one of the things that we want to do in this project is to evaluate the impact, and we want to the fine-tuning this robot in order to provide the better services with the feedback of the users. And we involve an institution which is in charge to evaluate this part of the feelings of the people, of the users with the robot. So
muchas gracias.
You're welcome.
And we have one more question from a student. What is the maximum latency for conducting a safe remote surgery?
The latency was 2 milliseconds in this trial.
Mm-hmm. And I suspect that you would like to reach the limit, the 1 millisecond. No, it will be even better.
Yeah, but now what we find in the pilot project is that the network provides a very, very good latency, but now the latency is not from the network. The latency is from all the devices, the cameras, the mobile phone. So now we have to work on improving the processors of all the devices in order to achieve a very, very low latency, which is the goal. So,
anyhow, thank you very much, Tomeu. We should jump to Pericles to start up again, the presentation. But these things happens whenever, Pericles better than me, whenever you run remotely events, you just hope that the technology will support you. Otherwise, probably you cannot even control it with 5G. So
yes. Thank you again. So this is part 2. Let's hope that my laptop just started to shut down. I don't know why. Probably the laptop does not like me. So you can see my slide, right? Yes, okay. So I was starting to say that we, in this seminar, we have not, in this webinar, we have not talked a lot of about the Internet of Things. However, it touches all our activities, right? We are all familiar with Internet of Everything, Internet of Things. We have, we in Greek, we have several ways to say, to translate Internet of Things, but in fact, what it is all about connecting things in several ways, and I will talk about some of them that use 5G. So, Internet of Things is everywhere. Here we have the example of some vehicles that are connected with the cloud and and provide some services. But we connect also people to things. I think most of us we have devices that are connected and they are located on our body or even in our body, especially for medical reasons. It's everywhere because sensor devices are much cheaper, and there is a technological advance anyway, so we can easily buy and use them. And there are a lot of verticals. Today, I'm going to talk about the connected cars, but as you can see, we have a lot of verticals that, if I'm not mistaken, all of them can utilize 5G technologies. So I will focus on connected cars, and we need to have in mind as well, since in among us, among the audience, we have a lot of students. So I will briefly refer to the main technologies that we have for networking. If we try to categorize them, we can do the following. We can categorize them according to the range that they cover. So we have the short range multi-hop communications with some well-known protocols like Zigbee and Wi-Fi and the our old friend RFID. The cellular approach that we are familiar with, and the low power wide area networks that we have Sigfox, NB-IoT, and LoRa, and many others that we're not going to talk about them today. So if we go to 5G requirements, I will not spend more than one slide in order to refer to them, since all our distinguished lecturers have referred directly or indirectly to the requirements, to the, let's say, to the performance metrics that we are very interested in. So what the 5G attempts to do, and is successful in many ways, is to provide all these services by achieving very low latency, increased battery life, so energy consumption is decreased, and of course to satisfy a lot of users in a specific, in a limited geographical region, right? So we talk about capacity, latency, energy consumption, cost, user data rates, and of course coverage. And then one other very important aspect is reliability, right? So the previous speaker was talking about medical applications, so you understand what is reliability here and what is latency, delay, and how important these two performance metrics are. Now, I'm going to briefly talk about the situation now. We've been talking and we've been hearing about smart cities. So a lot of people that are concentrated in a few cities around the world. And why do we discuss this? Because the number of cars that it's the main topic of our my talk today, is going to, the projection is to be doubled by 2050. So this actually is forcing us to talk about vehicles and how we can find solutions that will have more efficiency, a lot of efficient ways in smart cities. So more people, more cars. Let's start with the definitions. So I think that it's well known, the topic of intelligent transportation systems. And what we actually, what is the target here is to enable users to get better and more safer services, we can talk about smarter use of roads and transport networks. And this ideally should be combined not only with cars, but with metro, with buses, with a lot of other ways that we transport people or goods in a city or outside the city. Another definition that makes sense here is the self-driving car, that some times we see this as an autonomous vehicle or connected an autonomous vehicle or driverless car, which is the vehicle that by sensing the environment can move safely with little or no human at all input and control, right? So self-driving car, I mean, makes sense, but we'll talk about that later on. Autonomous can operate in some vehicle that can operate in some manner without constant direction from the driver. Connected, which is the main topic of our talk today, a vehicle that can communicate with other vehicles and infrastructure, so perhaps the road. In our presentation today, we're mainly focusing on cars. So no UAVs, no drones will be discussed, or trucks, or autonomous ships, or whatever it's related with the topic. Now, if we see some pictures, some sexy pictures about what is vehicle to everything, we see a lot of variety of connectivity, right? We can see vehicle to pedestrian, vehicle to vehicle, vehicle to network. We can even consider vehicle to grid. So the target is to get an increased I would say a super experience to the user, but in the same time also provide some services. Now, this is a representation of the different ways of that we can connect vehicles. So everything that I have I was referring to vehicle to vehicle, vehicle to device, vehicle to pedestrian, even vehicle to home, when we talk about energy, and vehicle to grid. And of course, vehicle to infrastructure, which is the connection of a vehicle to traffic lights, usually for traffic congestion and avoiding accidents. Now, some use cases that actually, when I was preparing the slides, I was trying to find some examples that will make sense also for Greece. Platooning, which is a well-known topic on vehicle communications, traffic light control, which I hope that someday we'll implement in Greece. Assisted route planning. If we talk about safety, then we have dynamic road signs. This is also a very interesting topic about in the Greek roads. Automated road sign reading from the car. Collision avoidance, which is always among the priorities. And of course, autonomous vehicles that is involving a lot of vehicles that they can, doesn't matter if it is taxis or if it is any kind of vehicle that can move in a with safety, with just sensing the environment. So these are the use cases that I will talk, for some of them I will provide some details. So platooning, you see the case, coordination by sensing and control, especially for the case that the driver, no matter if he or she is very good, is an excellent driver, is not able to know all the information about a potential accident, for example, right? And autonomous driving, remote controlled driving. Now, it's a very a big business about industry. So not only the car companies, but a lot of players exist in the area, and they invest a lot of money. So we see here even NVIDIA, that probably somebody thought that could not make any sense, or FedEx, which is transporting goods. Some of the companies, it seems that they are not industry car companies, but it makes sense to be involved in the whole story of autonomous and connected vehicles. If we talk about autonomy, then there are 5 or 6 levels, because if you go and search in the literature, some people refer to 5. But let's use the one that it's here. So no automation on the left side and full automation on the right side. And of course, here I would say that we are on the first or on the second level in most of our cars. And you can see that automation is the full automation is the ultimate target of autonomous cars, but still the technology is not so mature, I would say. So from connected, we are trying to move to autonomous. And we have some also issues that are related with autonomous driving, with connected cars and autonomous cars and vehicles. The ones that you can see here. So autonomous driving, intelligent hybrid and electrical vehicles, that is a very hot topic in the recent years. And other aspects of and issues that are related, some of them with software, some of them with intelligence, right? Artificial intelligence, and of course, modeling and identification of the vehicles. Now, if we look at, I'm not an expert in vehicles, but if we look on the parts that make the vehicle intelligent, smart, and able to finally being autonomous, then we see that there are a lot of subsystems that exist in the cars. Some of them we have already in our cars. Some of them are being realized, implemented now in the cars, either for experiments or some lucky people, unfortunately I'm not among them, can have some of these systems, especially if you buy a very expensive car. So some extra cameras, some radars, some sensors that will provide to the customer, to the driver, a lot of information that eventually could lead us to have an autonomous car. Now, why are we discussing latency and reliability? Because the environment that the vehicles reside is dynamic. So actually we see a topology that changes rapidly, very fast. And this is why we need to implement protocols that will provide low latency and will be very reliable. And of course, in some cases, there are priorities that we need to respect and we need to somehow accommodate. For example, you can imagine watching a movie not when you drive, but the passengers does not have the same priority with a very critical message for an accident that happened 200 meters in front of us. So we need to implement to somehow realize priorities as well. Interoperability is always an issue because we are talking about several cars, several different devices that coexist in such kind of environment. And of course, security and privacy that I'm not going to talk about. I have only a slide, but it's always a very important aspect. Now, this is a physical view of a potential network of vehicles. So you see vehicles that are connected with the traffic lights, connected with other vehicles, with infrastructure, and also we can even implement a control center if we are probably talking about a municipality like municipality of Thessaloniki, where I live, could control and could probably give priority to emergency services like an ambulance, right? This is the network view of a network. I'm not going to provide details about this, but you can understand that there are several parts. The architecture is quite complex, I would say. It's not easy to handle. And of course, we involve a lot of people, right? So we are not only talking about communications or hardware or sensors. We're talking about a lot of different areas and different parts that this system consists of. The main three, I would say, parts of the architecture is sensing, using all these sensors and radars and equipment. All this information that is being collected is needs to go and be processed and make the decision. And of course, we can control and we can give commands to the car or to some parts of the car. So we're talking about the integration of this system. And as I just said, security and privacy is always an issue because you can imagine what could happen. If we talk about protocols, there are a lot of protocols that are related with vehicle communications. Probably the most well-known is 82.11p from IEEE. But there are a lot of other protocols and standards that are currently and in the previous years are developed. So we have safety applications, no safety applications, several ways to implement the applications, the services that we would like to see in vehicles. Now, very few details about the spectrum. Unfortunately, it's not globally harmonized. So we have several bands, frequency bands that are available according to the countries. This is probably not the latest information because I've tried to look for what is happening now, and I'm not sure if this is correct or not, but it seems that we're talking about totally different, in some cases, totally different frequencies, and this creates, as you can understand, problems. Now, these are a slide that illustrates who is doing, who is developing standards. These are the main, I would say, players, and they have developed a lot of activities and standards in the previous years, and we hope that some of them will be implemented in the cars next years. Now, the cybersecurity, let's say, fear, the several vulnerabilities that could be exploited in certain parts of the system, and you can imagine what could happen if we if we get the wrong information from the car. So the decision that we take is the wrong one, or if even the car is autonomous and somehow we have a denial of service, so there is no information available for the car to make a decision. Or here I would like to say, apart from the security perspectives, there are also the ethical issues that I'm not going to talk about. You probably have seen what is going to happen when the car needs to decide. Unfortunately, there are two ways to go. In one way, the car will kill a child. In the other way, the car will kill, let's say, a 70 years old guy. So the car needs to make a decision because there is no time for the car to stop. So even ethical problems and issues that arise. Now, how am I involved with and how we are connected with the connected and autonomous vehicles? The good news is that we are coordinating a project which is a Marie Curie RISE project, and will start in June of 2021. And this actually gives us the opportunity to work with some partners and to develop scenarios on the area of vehicle to everything. So the partners are us, the coordinator, the University of Surrey, a university in Germany, in Malaysia, in Thailand, and a technology company in Bulgaria. The main objective of this project is to propose a smart millimeter wave multi-radio access technologies for multi-hop vehicle to everything communications. As you can see here, we have proposed a specific approach. This represents the three main research working packages of the project. And these are the main, I would say, the core of the project. As you can see, one of the targets is to enable timely exchange of critical messages. So we're considering something like this, which is very, very important for vehicle communications, because you can understand that the vehicles are moving very fast and the latency should be very low. So the millimeter wave that is the main part together with machine learning and intelligence are the main parts of this project. The target is to reduce significantly the interference from nearby networks and transmissions. We're going to use a test bed in two of the partners in UK and Germany that they provide facilities for vehicle to everything communications, and they have vehicles that we will use. Hopefully in 4 years, 4 years time, we'll have really important results to announce. I hope that in 1 year from now, we'll have some first results, and I promise to organize a seminar about that and invite you all you guys about this project. Now, another project, towards finishing my presentation, another project that we are partners is the Team Up 5G, which the main focus is not vehicles. However, we consider some 2 cases, if I'm not mistaken. We're considering small cells, which are formed by low power and reduced size wireless access points and devices. And the theory says that we can decrease a lot the power consumption. And we are considering, here we have a lot of partners, we have a lot of companies as well. And we are considering several use cases, mainly Internet of Things. And you see some of the cases that we consider. And one of the use cases that we do research in is emergency drones and vehicles. And this is very, very interesting because we also involve UAVs here, and we try to produce something that will make sense. Now, the last slide, so I'm finishing. I hope I'm on time. So what is the target of the connected and autonomous vehicles, and how 5G is related with? 5G, the target is to provide solutions to these cases, for sure. So remote driving, platooning, information sharing on, as I said, information that even if you are a perfect driver does not exist, but let's say that you are, you are not aware of information that will be very helpful to avoid accidents. And of course, video sensing, information exchange, and many other aspects. So I think that I need to stop here and give you an overview of the campus in Thermi in Thessaloniki, of the University Center of International Programs of Studies. We offer purely master courses in English, so I will be very happy to answer any question that you have regarding my presentation or the University Center of International Programs of Studies. Thank you very much.
Thank you, Pericles. Thank you very much for the presentation. Actually, we are on time. I think that we have 1 minute delay to the schedule. So any questions? I think that we have one question from Sotiris Tsalikis. When do you predict that we will enjoy fully autonomous vehicles?
Okay, I don't think that there is any safe prediction about this, because I've tried to explain, I don't know if I was clear, that there are many issues. And of course, there are 2 issues that are not technical. The one is that we're talking about investment from companies. So it's up to them and to invest enough money in order to develop and to bring all this technology to the customers. And the second reason that I would say that it's technical, but also not technical, is what is going to be the 5G deployment. I mean, Maria Bura in the beginning talked about that, and some other speakers. But really, in order to implement this, it's up to the 5G deployment in each country. So it depends on several factors, and I would say that probably an estimation is that in 5 years' time, I think that we'll see some implementations. But what you actually ask is how soon us will get the cars that will implement this, right? Because it will happen the same as with other technologies. the technology at the beginning will be very expensive. A few people will be able to buy that. But the real question is when you and me will be able to buy these nice cars that will avoid accidents and will provide all this information to the drivers. I would say that we need more than 5 years for this.
I suspect that, you know, the same challenges we face right now with the electric cars. I mean, if you come to Crete, you know, there are very few places that you can charge it, or with the gas. So there is another question from Safi. Do the autonomous cars require 5G technology? Because in the United States and Canada, long before Tesla have sold the cars which are capable to be autonomous, or they are half autonomous.
Okay, I don't know which implementation are you talking about, but yes, autonomous and connected cars, sorry? So we had autonomous cars with 4G, right? Or we were trying at least, but 4G cannot provide, cannot fulfill all the requirements of an autonomous car. So yes, we did experiments with 4G, and I assume that they were trying that with 3G, but they very fast, very quickly, they dropped the efforts. But 4G cannot implement low latency, very low latency, and is not so reliable in order to implement a really autonomous vehicle communication. I suspect that you are talking about some attempts, but if you have more information, please send it in the chat in order to be aware of that. But I'm not aware of any real implementation that has all these requirements fulfilled. Okay.
Thank you, Pericles. I think that we should thank you again for the nice presentation and the support. We should move to the next speaker. We have two more speakers. Thank you, Pericles. It's nice to have with us a neighbor, almost a neighbor. Slovenia is not next to us, but we consider them as a neighbors. We have with us Mr. Damir Opsenica, if I pronounce correct your name. He comes from a Slovenian telecommunication company, Iskratel, and he's going to speak to us of the impact of 5G to the digitalization of the industry. So Damir, Pericles, you should stop sharing the screen with us.
Do you see my screen now?
No. First, Pericles should stop sharing the screen because Pericles has blocked us now.
Okay.
Pericles, are you with us? How can I? Pericles? I think that he left his computer. Let me send a message. Let me call him actually.
But I think Konstantinos, try to remove him, because I think if you have a control,
yes, this is a good idea.
Just to remove him, and then yeah.
This is a good idea. Thank you.
Okay, now we are there. Now we are there. Okay. And tell me when you see my screen.
I can see your screen.
Okay, very good, very good. So thank you very much. Thank you very much for the opportunity. So and I think this is not, at least not for me, the first time I'm talking with you, with the friends from Greece. So it's always nice to hear basically as well thoughts and situations and ideas basically coming from your part of the world. So let me deep dive in the slide pack, and for the introduction, you know, I think you already made an introduction, but this is just a kind of position ourselves that you know with whom you're discussing. And I think it was a very nice to start with the vendor, and now somehow until the end you have another vendor coming from the telecommunication industry. So a little bit about Iskratel. So we are not the new on the market. We are kind of a 70-year-old vendor, just recently acquired and became a part of the S&T group. By the kind of orientation, market orientation, we are orienting ourselves as a regional champion for the industry digitalization and communication. We see ourselves as the leaders, especially in the railways, energy utility, safety, industry 4.0, and what I already mentioned, we have more than 70 years, I would say, coming out of the telco space as well. Just recently, means this year, we created the new DSP, so the first of that kind in Central Europe, so digital service provider, with a specific orientation to provide 5G solutions to the industry verticals. The name of that one is the Beam, and so this is the new kind of a commercial model that we are starting with. So who am I? Some of the slides that you will see might basically be tacky. The reason why is that because I'm originally contaminated telco guy. So all of these acronyms are coming basically from my history of bringing myself basically from the legacy to the startup. So similar like a colleague at the beginning, I was a long time basically with Ericsson. And then lately, during the last couple of years with Iskratel, and now being basically in charge and director of the new DSP that I was already mentioning. Okay. So where is this bringing us? I think there was I saw many interesting presentations, and I think we are all discussing about that 5G as a technology has a bright future. Nobody is doubting about this one. I think I'm just kind of bringing here a slice of the marketing messages that we are kind of facing in last year. So from the Qualcomm to Nokia to Ericsson to GSMA, you know, there are trillions there, there are billions there. But the question is not about are they there? The question is somehow who is promoting the business at a moment, who is mainly pushing the business, and who is pushing the need in the sense. So the next slide will tell you a little bit about it. And I think when we are discussing about economy of the scale and business propositions for the digitalization of the industry, this slide will as well give you some sort of the insights why the main messages, and even on this call, why the main messages are basically coming from the telecommunication, telco industry, and who else is there, and how basically industry as such is taking the ball in all of these communications. One of the kind of the realistic situations where we are, and this is where we're standing at the moment. I think there is a very kind of important aspect coming from the telco industry as such, and business of the telco. So the curve between the profit of the industry and the curve between the cost of the industry is getting very close. So that's one of the kind of the alarms that usually kind of you need to invest in something.
Damir, sorry about this. Can you place your presentation in the full screen, because now we can see it's on the presenter's mode.
Okay. Sorry for that. I can do that. Let me then just do something else. Let me just do something else very quickly, and then we go like this, and then. And I will go to the presentation mode, and just tell me if it's okay now. Is it okay now?
Now it's okay. Thank you.
Okay, very good. So, and hope, okay, so I'm continuing in that. So here is the first kind of a question point, you know, like the industry that is driving it is obviously the telco industry. So this telco industry is not so much contaminated in the same way on the same places. So what you can see that somehow our region, like Europe, when it comes to the operating revenues of the industry, is losing quite a lot, I would say, in the last 10 years. While the situation with the US or Asia, basically, it's a little bit more brighter, a little bit nicer. On another side, you have 5G that is bringing a kind of a very extended value chain. And when you ask the kind of the industry players, how big is the value chain? In some analyses like McKinsey, you get an answer that 90% of the revenue and industry kind of players should come from somewhere from the area what they call the neutral hosts. So that's another point that basically makes a quotation more complicated. The third point that makes the quotation even kind of more complicated is the point who should basically play with whom. Because you have on the top of the right side picture, you have the guys that have a very good economy value, quite good basically and solid business, while the telco you can find somewhere below with a 6.5 basically coefficient, and this is something what is kind of a questionable moment. Are those guys basically from the top willing to collaborate, and in on what way basically with those guys that have a kind of a worse economy or kind of a very bad economy value at the moment. So this is the challenge when you target all of these billions from the slide before, in the way, how do you want to target those? At the end, when we see the 2020 and the industrial 5G use cases, you can say even based on the standardization, and we saw today as well the informations coming from the radio networks and so on, you can say that somehow we are really early adopters. Why we can say that we are early adopters? Because that even standardization, what was mentioned a couple of times of this call, are kind of assuming that the biggest part of the standardization point of so-called 5G will come basically in the following years. And this is when I'm targeting basically 3GPP 17. But to have the kind of the picture complete, you can have basically what Gartner is saying about their estimations, where the 5G should sit and where the 5G and when the 5G should monetize, and they are not even putting it in the middle of the circle like that. So you have quite many of those new technologies like Wi-Fi 6, artificial intelligence, SASE and things like that, that are basically different, I would say, emerging technology aspects that, for example, Gartner sees even before the 5G to take place in all of these monetizations that we were showing, I would say, as an optimistic picture. Now, the sweet spot, I would say, of Easkertel and the insights that will be shown, I would say, in the next couple of slides. We're building around the industrial IoT approach. What you can see on the left side of the slide is that how to, in general, position the 5G there. So when you are going basically to discuss with the industries that we are kind of touching as an Easkertel, usually the 5G discussion comes in regards to the connectivity and physical world part. The rest that is related to the data middleware and applications and all of these nice things about augmented reality, artificial intelligence, big data, digital twins, these are the kind of the language aspects that those guys are speaking about and thinking about when they are exposing their needs. Put all together, I would say, and then you get an industrial IoT stack in which kind of Easkertel is investing, I would say, heavily at the moment. Are we doing it alone? No, that's another aspect, I would say, of industry and learnings that we have. No, we are not doing it alone. And one of the partners was obviously kind of mentioned already. This is an S&T group. So you cannot do it alone. So like we were seeing on the picture before, the way how we are selecting the partners and ecosystem is exactly to reach the kind of the use cases from the industrial IoT that we want to target. Which use cases in particular, I will talk a little bit about them in the next slide. So one of the use cases that we spent a lot, I would say, during this year and the last year was the industrialization of the productions, so-called smart manufacturing. So what we kind of started there, we introduced the 5G, we introduced the all of those things that basically should come from this 5G, like strong security, ultra high reliability, ultra low latency. Those are the KPIs that we introduced to start learning, you know, is this kind of the real need, and how much this is touching the need of the production. We had a fortune that Easkertel and S&T has a lot of the production lines, So we are kind of first bias, let's say like that, are internal kind of guys and internal companies that are starting to use the digitalization aspects of the 5G. We see that somehow we already see the need in a sense. So at the moment when we are discussing about 5G, we already see that there are the things that where the 5G as a technology, as a digitalization aspect may make sense, especially for the parts of the industry that is a kind of a moving parts, like moving vehicles, moving people. In which somehow the 5G could play and is playing the kind of a neighbor, very good enabler basically to address the needs. But other than that, we are as well based on the kind of the capabilities that we are getting from the 5G. We are developing as well the upper layers of the digital twins to be used, I would say, as a pure full stack of the digitalization of the Industry 4.0. So if I kind of can summarize, you know, how the story looked like a year ago, I think that in a year ago, when we approached the Industry 4.0, the acronym of 5G was a complete unknown. But once when you start peeling the whole storyline and expressing, you know, how the 5G can help in the particular problems that industry and production industry had, I think then you get basically to the understanding point, and even here you have a quotes of the director of one of the production lines, saying that today he completely understands why the 5G and how for example, 5G and augmented reality and artificial intelligence work together to get basically what he wanted to have, more efficient production at the end of the year. When it comes to another case that is as well significantly important for us is the energy sector. And I think in energy sector, we are about to see, and I hope basically it's the same in your geography. We're about to see somehow the full digitalization of so-called smart grid and convergence with a communication network. Why is this important? I think we identified quite many cases where the monitoring and automation of the network is not possible with the technologies that somehow those guys are using today. Then the second thing is that when you have alternative sources of energy like solar, like wind and so on, to have a monitor of all those kind of inputs in your network, you have to have a kind of a very robust scale network to provide you with this info in time, and that you can kind of monitor and automate the network. So those two were kind of an obvious needs that we met, and where we kind of introduced the 5G to help with the industry problems. And then somehow all other aspects of augmented reality used, for example, for the monitoring and the cases like a quality control, we made sense out of that because so far I would say with the technologies like NB-IoT or LT, they didn't have a kind of an opportunity to use them in the full volume perspective. Then the next one that is kind of a very crucial, and I think from perspective of roadmap, we can put it kind of in years to come. We saw that somehow there is lots of these things about smart cars, smart autonomous cars, and so on. But I think that one of the things that somehow should happen before is to prepare the infrastructure for it. So what we are currently doing, we are working with a local transport road organizations here in this part of the Europe to get the harmonization of the digitalization of road on the European level between the Slovenia and the neighbors. Special first kind of a case that we are touching with the roads is the safety aspect of the roads and technology to enable, and you will see what I'm saying basically on the next slide. the technology that should enable safety of the traffic. Then the resilient operation of the critical infrastructure. Then one more time, the digitalization through the industrial IoT of the devices that roads are using, traffic flow management, and then at the end, self-driving cars management that somehow comes as a final mile, because you are doing all of this that enables self-driving cars to work. The third one, but the last one, I would say from the transport perspective, is the railways. We can say that somehow by the references that we have with the railways, we are covering at the moment most of the railways in the Europe with the GSMR technology. And I think that's just a standing point at the moment, but the railways in the next 3 to 5 years will mainly start digitalizing themselves with the new communication standard, FRMCS, which should enable the digital rail operation and bring it to the reality, and it should enable as well so-called the gigabit train capabilities. So all of those multimedia stuff to be kind of enabled in the usage of the train, not just the trains, but basically people that are driving the trains.
4 more minutes.
Yeah, I'm getting there. Don't worry. And then, last but not the least, I was mentioning a couple of times safety. We were in last 2 years we were selected by Slovenian government to drive the 5G safety program for the first responders, similar like in Barcelona, let's say like that. Some of the kind of cases that we needed to implement is the securing the mass event, border surveillance and control, setting up the emergency call richness, setting up the first responder support, and the setting up the traffic control in the case of the incidents. And in the middle, you know, what we needed to do for the government, we needed to set up the next generation operation center to enable this one. The very interesting moment is that at the moment, if you check basically this technology, we have a fully fragmented market with lots of the legacy communication technologies that are supporting all of those cases. And then from perspective of the 5G enablement, 5G should offer the convergence of those ones in so-called 5G PPDR aspect. And then this brings me to the last slide and the final conclusions. I think from all of the presentations, including I would say mine, I think it's quite clear that 5G as enabler is a no-brainer. That's the standard. That's the thing that somehow will drive the digitalization of the industries. But what is not, I would say, so clear and uniform is the use cases. So what comes, and I think if you don't kind of select each of them and take them, I would say, in the tailoring way, case by case, to understand the language, understand the need, you might have an issue as well to explain for what exactly 5G will be used for those use cases. And then finally, one of the things that we are kind of exploring at the moment, and we see that somehow it is a kind of a huge, not just us, but as well the competition that we have on the market, it's a huge interest for it. We see the huge interest for non-public networks and usage of the edge cloud technologies to enable all of these nice KPIs like low latency, 1 millisecond, and all of these things that 5G should bring in. So this brings me to the last thing, to thank all of you guys and to be open for any of the questions that you might have.
Thank you, Damir. Thank you very much for the nice presentation. Do we have any questions from the audience? In the middle time, I would like to ask Damir your perception, because everyone speaks about the transition from 4G to 5G, and this is a very big issue. It's like, you know, the impact is like much stronger than the impact of the transition from the 3G to 4G. So what about, you know, everyone, before the 5G comes, everyone speaks about the 6G. So, I mean, the transition from 5G to 6G, it will have, and it will bring what it will bring. I mean, I'm surprised. Now I can see that we can do remote surgeries, you know, far away. We can fly drones. We can fly with autonomous cars. They will be on the motorways. My taxi driver can read his newspaper, and I will sit behind. I mean, what do we live for the 6G?
Yes, I think the dynamic of all of that you mentioned, you can see the dynamic is there every second, every minute you get a new use case that you can use. One of the biggest challenges I would say that the industry as such should cross and should enable is the much more smooth move from the 5G to the 6G than we see at a moment that is kind of a plan between a 4G and a 5G. The reason is the speed. So the use cases are there. The use cases will come, like holograms and much bigger speeds, like remote surgeries, tactic Ethernets, and so on. So the use cases will be there. But I think that one of the biggest challenges of the 5G is that it's showing the peak and complexity of the jump between a 4G and a 5G. And when you ask me about a 6G, I really hope that somehow, while I'm reading all of the researching material around the 6G, I really hope that the transition from the 5G to the 6G will be seamless for the use case examples that you are mentioning, so that somehow that those consumers will not feel the difference, but will feel a kind of a very fast benefit out of that.
Thank you, Damir. There is a question from George Agapiou from OTEC Group. What is the value chain for an operator to use a fully flexible dynamic management platform offered by 5G?
Yeah, that's a strong one. I think one of the challenges that all the MNOs have at the moment is that how much they need to invest in OSS BSS and what is the border of this OSS BSS. So in the sense of the management system. So because you are kind of making the complexity of pulling in the industries in their networks, the question is, what is the scale? I think it is what I think something what has to be taken into consideration in the very early plans of the 5G implementations. Because you need to understand which use cases you will cover, which industries you will pull in. The problem with the MANO and all of these kind of optimization and monitoring mechanisms that you have in a telco is that they have to work as well with the existing industrial management systems. To make this one, you need to plan early to make the transition basically seamless for the industries that you want to pull in. So I think that's definitely the crucial one, and my take is it has to be taken into consideration in the same time like when you're starting to plan your radio network.
Thank you, Damir. I think thank you again for your contribution and your presentation. Since we don't have any, actually I have one. So regarding, I will come back to the chip makers. So the whole security issues regarding 5G, do they come from the chip maker or does it come from the whole setup, like the MIMOs or these transmitters and receivers? The security issues regarding 5G, from where do they come?
They come, the security as such as we see it, it's a very holistic. So 5G is opening the kind of the network on many areas. It's opening it from the IT perspective, I would say, from the management systems perspective. It's opening it as well from the usage perspective, I mean, from the device side. So and it's a holistic approach. So I think in the same way, like the defense or kind of situation about security can come from the different OT, I would say, industrial devices. You can get it as well from the side of the management system, from the side of the market approaching to the particular industrial basically networks. So it's a holistic approach that everybody has to take in the planning. One more time, the budget-wise, it has to be planned accordingly so that you don't kind of miss the budget that needs to be invested in the cybersecurity. And I think one of the biggest kind of learning points that we kind of identify in our work is that 90% of it comes by the human mistake. So this means that management systems and automation systems that you are using for your new 5G infrastructure need to kind of mitigate on the human mistakes and need to kind of put a much more automation in the process than it is currently available.
Thank you. And the last question, and please, just give, a very fast reply comes from Yanis. Will we become more vulnerable? Oh man, I'm tired now. More vulnerable to attacks as there will be more data traveling in the open and stored in the cloud servers? Will hackers, for example, have more opportunities to disrupt our devices? And lastly, can 5G be used for surveillance?
Yes, I think, okay, those two are a little bit kind of different. 5G is being used for the surveillance. I think that what 5G is enabling is it is enabling extraordinary good uplink. And that's I would say one of the biggest needs of the surveillance systems, because you put much more data to the network, not to the end side. And this is where surveillance comes in with all of these 8K cameras and all of these things and automation on top of this. This is where it is. When it comes to the security, I think the same question. I think with lots of data, you get a kind of a very big challenge of handling that data and taking the security on this one. What we see out of the, for example, factories that we are kind of supplying today with the digitalization, one of the main aspects is how they secure their data. And this aspect is being kind of put into the plans from the day zero. So how you can secure the data integrity, how you can secure where the data on the set or the server is, what is the kind of a security of the cloud, how much you're using public, how much you're using your private cloud, and all of these kind of aspects come, I would say, from the day zero for the industrial players.
Thank you, Damir. Thank you very much indeed. So let's move to the last speaker of this webinar. It's a great pleasure to have a colleague of mine from the Hellenic Mediterranean University. It's Professor Evangelos Kokkinos, and I think that he is going to speak of something very hot regarding the health impact of 5G communications. A lot of people, they are asking, and there are a lot of rumors about 5G and the impact of 5G and the consequences of 5G to our health. Evangelos is a telecommunication engineer. It's not his field, the healthy issues, but he's the most appropriate person from our side to speak about this. So, Evangelos, the floor is yours.
Thank you, Kostas.
Share your screen, please.
Can you see my screen?
Yeah, we can see your screen. Please maximize the presentation.
Okay.
Excellent. The floor is yours.
Okay, thank you very much for the whole organization of this webinar. 5G is one of the topics that I am very interested for that. Actually, as you mentioned, I'm not an expert in safety things about 5G. I mean, we are talking about health issues. But a lot of students ask us about how safe is 5G. So that's why we prepare this presentation. As you see from the outline, we are going to talk about radiation a little bit, and we see the electromagnetic spectrum and where is the mobile communications and where is the non-ionizing, which is in non-ionizing radiation. And of course, we're going to talk about frequency ranges and channel bandwidths, and address about safety limits if there are. Of course, there are. And what experts said about 5G and health. And also, we're going to speak about the new technologies that 5G uses and how this affect the health issues, let's say. And finally, we're going to talk about 5G and coronavirus, which is a bit funny, but anyway, we will address it. Okay, let's start. at the beginning, it is important to distinguish the two kind of radiations that we have. One is the ionizing radiation, which is generally considered as hazardous for humans. Includes gamma radiation and X-rays, and the non-ionizing radiation, in which mobile communications and electromagnetic electromagnetics applications is in this area. Let's see the electromagnetic spectrum. 1 minute. Okay. As we see in this spectrum, in this picture, we see the non-ionizing range, which is from, let's say, hundreds of megahertz up to ultraviolet radiation, and the ionizing radiation, which is X-ray and gamma rays, as we already mentioned. And we can see that mobile communication of previous generations, 2G, 3G, and 4G, are in the areas of 800, let's say, megahertz, up to 2.6 gigahertz for 4G. Excuse me. And 5G can use also the frequencies of the old generations. So we can say that we can reuse these frequencies with 5G, and we have two bands. The low band, which is up to 6 gigahertz at the beginning, but we can extend it up to 7 gigahertz, and the higher band, the millimeter wave bands, which is from 24 gigahertz up to 100 gigahertz, but the implementations, as we see here, the implementations up to now is up to 52.6 gigahertz. Okay, let's go to the previous one. So as we see here, the radio waves used from 5G is in the spectrum of previously used from TV broadcasting and wireless broadband communication. And also there is another band, as we already mentioned, in millimeter waves, that they have some trials, and they are not implemented in the early stages in every place, but I think it is implemented in the United States. These two bands are from, let's say, 410 megahertz up to 7 gigahertz approximately, with an extension. The lower band is important for the operators because, as we know, the path loss in higher frequencies is very, very large. So operators, if they want to cover the cells, they mainly use the FR1 band. And for hotspots applications, we can use FR2 band. Why we use those bands? As the previous speakers, distinguished speakers, Professor Karagiannidis already mentioned, and Professor Kanatas, the more the bandwidth we use, the higher the speeds that we have, more bit rate, of course. And as we see here from this slide, the channel bandwidths from FR1 band, they are going up to 100 megahertz. As you see, the channel bandwidth is scalable, like 4G, but we have greater channel bandwidth here, and especially in the FR2 band, where the channel bandwidth is up to 400 megahertz. That's why we use this FR2 band. But the big question is how safe is 5G? So are there safety limits for 5G in radio waves? This is the first question that we try to answer here. The answer is yes. There is guidelines. There exist guidelines, and there is an organization which is called International Commission for Non-Ionizing Radiation Protection, which sets these guidelines and includes substantial margins of safety to protect all people against established hazards. These guidelines have been widely adopted in standards around the world and are approved from the World Health Organization, which is responsible for the health of the planet. Okay, so what do the experts say about 5G and health? One expert is the World Health Organization, of course, and it said that despite extensive research, to date, there is no evidence to conclude that exposure to low-level electromagnetic fields is harmful to human health. Also, the World Health Organization said about the wireless networks and health, considering the very low exposure levels and the research results collected to date, there is no convincing scientific evidence that weak RF signals from base stations and wireless networks cause adverse health effects. So this is what they take, what World Health Organization talk about the networks. What about the mobile phones? The mobile phones is responsible for 99%, let's say, of the radiation that a human receive, and only 1% is from the networks. This quote I heard yesterday in a forum that I was watched about the radiation and radiation about 5G, and it was a GSMA 9th forum about electromagnetic fields. Okay, forum. About the mobile phone, because the mobile phones are responsible for the heating of some heating of the head or what else is around. A large number of studies have been performed over the last 2 decades to assess whether mobile phone pose a potential health risk. Today, no adverse health effect has been established as being caused by mobile phone use. This is from the World Health Organization about this, but the World Health Organization continues to encourage research parties to research about the use of mobile phones, because there is a lack of data for mobile phone use over long period of time. For example, more than 15 years. And what the risks about brain cancer there are. So the recent popularity of mobile phones among younger people and therefore a potential for longer lifetime exposure, World Health Organization have promoted further research for this group. So several studies investigate potential health effects in children are underway. Okay. Now, from 5G base station, there is a company Ofcom, which is a UK communication regulator, which carry out measurements to confirm how the base stations transmitter, if they do not exceed the restrictions set out from IEC and IRP guidelines. What they told about the Ofcom. Ofcom told us over the past few months, Ofcom has measured radio waves emissions level at 5G sites in 10 UK towns and cities, and in all cases the level recorded are a small fraction of those that IC and IRP guidelines said. For example, the maximum measured was about 1.5% of the guidelines levels, including signals from other technologies, because as we heard in this webinar, there is coexistence in the base stations. At the beginning, there are base stations for 2G, 3G, and 4G. And in the same base station, we have also a 5G technology base station. So the overall exposure, let's say, it's 1.5% of the guidelines levels. And the highest level from only 5G signal, only 5G, it was less than 1%. Of course, Ofcom will continue to monitor 5G signal levels in UK. And there are also, in every country, there are also these regulator authorities. In Greece, for example, it's also another body that measure the radiation from the base station and see if there is any base station with more power than the IRP suggests. So let's go to the next slide. How the technology advance of 5G affect, let's say, the exposure of the frequencies. One of the main things that we have in 5G, we have the millimeter wave band. In the Netherlands, this band is not used. They have suggested they will not use this millimeter wave band up to at the beginning of the 5G rollout, in order to have more studies about the consequence of this band to the public. And also in the UK, as we see here in the next bullet, the mobile phone companies use use band from 700 megahertz up to 3.8 gigahertz. In this band, we have also 2G, 3G, and 4G as well as the 5G deployment. Okay. Now, in the millimeter wave band, It is in the higher spectrum, as we see, and we have some trials, 5G trials already taken place for these frequencies. And also in the United States, we have operators that they use 26 gigahertz and 39 gigahertz frequencies. And of course, the advantage of these frequencies, as the previous lecturers already said us, is that we have higher speeds because of the larger bandwidth and very low latency, and also we can use massive MIMO antennas with the lower sizes, because the distances between the elements, the antenna elements, is lambda over 2, where lambda is the wavelength. So as we go up to the frequency in the millimeter waves, the wavelength is shorter, so you can implement the massive MIMO, which it needs more than 100 antennas in a lower size antenna in the millimeter wave, so we can have this implementation easier. The disadvantage of millimeter wave is, of course, that the signals do not travel as far because of the great path loss that we have. The path loss is huge, so it is only for a couple of meters, and it is only for hotspots where there is a high traffic demand. So we will have implementation for these purposes. Okay. Actually, these frequencies are not new because they have already been used in many years. But for other applications, for point-to-point links, for satellite Earth station and radio astronomy. The ICNIRP guidelines cover all frequencies. We have new guidelines from March 2020, which cover all the frequencies of 5G and additional restrictions that we have in the higher frequencies. About massive MIMO, already Professor Kanatas had give us a lot of information. So here we can say only that with massive MIMO and beamforming, we will be able to direct signals only to where they are needed. For example, we can understand with a MIMO, multi-input, multi-output antennas, we can understand the direction of the signal of the subscriber. As a human being with 2 ears can understand where in the direction of a noise. For example, if I have a noise from this direction, I can hear it with my right ear better than with the other ear. The same thing happened with the antennas. So if we have multiple antennas, we can understand the direction of the signal, and we can only, with beamforming, we can only transmit a narrow beam to that subscriber. So the overall interference is reduced because we are
targeting 5 more minutes.
Okay, thank you. We are targeting the subscriber that we want to communicate with. Okay. Small cells, of course, small cells, they have been addressed previously, but from my point of view, from the point of view of exposure, from radiation exposure, etc., the more cells means that the signal from the base station is very good, and with the power control, the devices operate with much lower power. Because the mobile phones are very close to the base station. Okay, so the signal do not need to travel far away. That's why the power of the signal is very low. This means that our mobile phone, which is the major radiator of us, transmit with a very low frequency. Very low power. Excuse me. Okay. I think that we go to the last part of the presentation about 5G and coronavirus. Recently, conspiracy theories have been shared online that claim that 5G mobile is connected with the spread of the coronavirus. Of course, this is wrong. There is no scientific basis for that or credible evidence of this claim, of course. Also, the World Health Organization has an announcement about that. Anyway, in a lot of countries like UK, who have vandalisms in mobile phone masts, also engineers from the mobile phone operators have been threatened in the street while they work, and we have those things, very, very bad things happens in the 21st century. Anyway, as I already mentioned yesterday, I watched the 9th GSMA EMF forum, and Professor Stefan Lewandowski from Bristol University, psychologist, said that in all the epidemics from the last 300 years, people have been developed conspiracy theories to justify the situation. It is a psychological need of theirs. At first, many times they do not accept that there is a pandemic, and when it happens to them or to those around them, they develop these conspiracy theories to say that others are to blame for what is happening to them. The other question, why do they blame 5G? From the same professor yesterday, he said that it is invisible. The coronavirus is invisible. Also, the 5G is invisible with the naked eye. So they have this both technology and the virus. And also, there was a negative article about 5G in 2018, and from a major media outlet that started these negative rumors about 5G, and also we have continuation of these rumors. Anyway, that's my talk and the references, and I would like to thank you for your participation up to very, very late time now. Okay, thank you very much.
Thank you, Evangelos. Really appreciate for your participation, presentation, and organization of this webinar. There is one question. Is there a need to close 2G and 3G services in the future and instead use the spectrum for 5G and beyond? I mean, this is not related very directly with your presentation. I don't know, probably we have George Agapi, who is still with us. I will say from what I have read, all the reports that I have read, it is like the 5G is not going to operate, we're not going to operate directly to 5G, but also we will have the support of 4G. And we will be in,
actually, there is a actually there is a coexistence of the generations.
All right.
We have already 2G GSM now, even now, which is a technology from 90s, but we use this for voice mostly. But also have 3G and 4G networks in Greece, which are from data. But as George Onopas, my friend from OTE, said that the cost from megabyte is lower in the new generation. So 3G is more expensive to use 3G technology in order to have data. So 3G will reduce, let's say, we stop 3G, for example, and we use 4G and 5G.
Okay.
Thank you.
And also, this is like a comment from John S. that Cosmote is closing 3G at the end of 2021. This is on agreement on what did you say. So I think that we should stop here. We have started at 10 o'clock and now it's 4:30. I would like to thank all of you. Evangelis, please stop sharing.
Okay.
And I would ask for the last time. No. Okay, thank you. So I think that I should stop here. Probably I will ask from you to go again to Mentimeter together, just for the people that they have not registered, just to have an idea of your profile and your participation here. So for the people that they have not answered these questions, let's spend together 5 more minutes. For the rest of you that you have participated in this, how can I say, in this voting, I would like to thank you very much for your support, participation. I really admire your patience to be with us so many hours, and hopefully we will meet again in another webinar. For the people that they follow the International Week, I will send you an email within the next 2 hours for the Zoom link for tomorrow. So I will request for the people that they have not participated in this Menti.com voting to be with me for the next 5 minutes, say, in order to complete the survey. So thank you very much. I would like to thank the organizers, Vangelis Kokinos, Ricardo Tavio, the IEEE, you as a participant, and see you in one of our next webinars. Thank you and have a nice night.
Thank
I
you,
will stay only.
Bye-bye. Thank you.
Thank you, everyone. Thank you, George.
Bye. And I will stay only with the people that they have not done, the voting.
Okay.
So let's see how many. So let's move to the, are you familiar with this? So anyone can go to www.menti.com and use the code up there in order to have a better idea of your profile and try to become better in one of our future events. So very well. So let me move to the next one. So please, for the people that they are still with me, please register your sex. it's obvious that we are talking with engineers because the females are very few, and the males they overrule the domain. Okay. Let's move to the next one. The field of your studies. Thank you. Let's move to the other one. Please inform us about the name of your institution, your company. Very well. Where does your institution locate? So it will be from Greece, from the previous answers, and Slovenia probably. France, yes. Thank you, Michael Bosco. Okay, let's move to the other one. Why do you participate in this webinar? Very good. Let's move. How do you learn about this webinar? Very good. They still vote. Okay. So I suspect that I should stop sharing now. Thank you again for your participation and your patience. And I will share with all of you the link in YouTube channel where I'm going to upload the whole webinar. So for the people that they participated in the International Week, we will continue tomorrow at 10 o'clock with a presentation and contribution from Bulgaria, Professor Dimitar Arnaudov. And then we will move to an invited talk regarding geology from Saudi Arabia at 11. And then we will continue with the presentations of the universities. So I will request, I have a list of universities that they will be presented. It will be nice for the students to participate in this in all sessions, because tomorrow is the last day of the International Week. And then at 2:30 CET, which means 3:30 Greek time, we will continue with our final webinar on the frame of this Erasmus Week regarding mathematics education. I think that the students, they will love to follow this, because we're not going to teach mathematics, but we're going to teach how to teach mathematics, which is much different. I will send an email tonight about all these actions. I would like to thank you and wish you have a nice night. Bye and take care.